Tonight we're focused on the opposition of Mars, and if you saw our thumbnail, that gets across the main idea. You have that big picture of Mars on the left, and then on the right you have the planets in a line, which represents the opposition. It's a simplified take on it, but that's the main idea. You have the Sun, Earth, and Mars lining up, sort of a celestial alignment there. And as far as astronomical sense, on one hand, the idea is you have Mars rising in the east and the sun setting in the west at basically the exact same time. And that's where that name opposition comes from. They're on opposite sides of the sky, like 180 degrees, right? If you think of our celestial sphere. So they're on opposite sides of our sky, and the other big astronomical importance of this event is that we are very close to Mars. And if you joined us on Friday night, you would see, and you can of course go back and watch that video too. But we were observing Mars, and we were pretty up close. Now there are a couple of there were a couple of issues on Friday, in that our seeing wasn't great. And seeing is a measure of the atmospheric turbulence. So when the seeing is poor, it means planetary detail is blurred, and a lot of data or information is lost as that light from Mars enters our atmosphere. If we were able to escape Earth's atmosphere, we'd have no problem. Imaging Mars at all. And that's why the Hubble can get such good images. But down here on Earth, we're peering through a lot of atmosphere, and especially when Mars is just rising, we're peering through even more. So when I first got the telescope on, just about 45 minutes ago, I was peering through a significant portion of the atmosphere, and it was very turbulent. And I suspect that's still roughly the case. But an hour from now, 2 hours from now, that will improve as Mars gets higher up in the sky, because you're going to be looking through less of our atmosphere. Furthermore, we expect that the seeing is going to improve tonight. And again, that seeing is a measure of atmospheric turbulence. So if we go through and look here, I'm going to bring up my screen. And this is also for anyone new to our channel. Welcome. It's a good opportunity to, see, there we go, computer screen, share Kopernik Observatory's website, kopernik.org. There's also links in the video description for our Facebook, Instagram, and Twitter. We are active on those social media platforms. We post the latest NASA, the space news in addition to NASA news, and our latest programs that are coming up. So if you want to stay up to date on programs like this, as well as our presentation-based programs, like our Friday night lectures, then that's a great place to go. If you have not subscribed to our channel yet, you can hit the subscribe button, and that'll keep you up to date as well. Okay, so Kopernik.org is another place you can find more information. Here's our program here tonight on the opposition of Mars. We just announced that the Kopernik Science Park is now complete. It's just outside the observatory here. That's where I am. You can see the telescope behind me. I'll get to that in just a couple minutes. So the Kopernik Science Park is now finished. Now, ideally, we would have held a grand opening and invited a lot of people to come up here, but unfortunately the pandemic does not support that. So we're excited it's all done, and you can view the website for more information as well as Facebook. So going down, we're having live streams for the foreseeable future. Our events are virtualized, so YouTube is the best place to access our programs right now. We have AstroFest coming up. I think it's the 24th. Is that a Saturday? Yep, there it is, AstroFest 24th. That'll be a program sponsored by the Kopernik Astronomical Society. They're leading it. We have a bunch of different presentations planned, and potentially I'll be able to do a virtual observing stream that night as well. as long as it's clear. If not, I'll find something else to talk about. All right. And one thing you can do is you can come down to the bottom of our website and hit the click here to view current and future sky conditions. And this is if you're local, or if you're interested, if we're going to hold a stream, what the conditions are like if you're not from the area. This will inform you about what the sky is like up here at Kopernik. So dark blue is what you want to see, and so our cloud cover is looking good for tonight. Transparency, that's a measure of the particulates in the atmosphere. You can think of that from water particles to smoke. You know, we've had a lot of wildfires across the United States, so smoke comes into play there as well. So transparency is looking good tonight. The seeing, which again is that measure of atmospheric turbulence, it's a little bit iffy. On the 0 to 5 scale, I think it's going to read as a 2. It's saying poor, but it looks like it's going to improve as the night goes on. I'm not sure if I'm going to keep this stream going until 1 a.m., but we'll see if the sky improves. The transparency is noticeably better, and even the seeing is a little bit better from Friday night. So I think we'll get better results from Friday. All right, so sky's looking pretty decent for tonight. I'm looking forward to observing. So if I do want to make sure that you all know the way we handle our streams and our chat. We definitely welcome you to ask any questions you have about what we're looking at in our scopes, about Kopernik. Any questions that come to mind, feel free to answer them. I'm going to do my best to watch the chat throughout the program and answer those questions. But we also have a great community that you can interact with in the chat and communicate with them too. So I encourage you to just spend some time with these like-minded individuals. We're all here to observe the sky together, and we're excited to be able to share that with you virtually. So looking good there. Make sure my volume's down. I want to make sure that chat is updating live. There we go. Okay, so a couple of things about Mars, getting into the focus of today's program. A couple of resources that you can use tonight, especially if you have, if you're watching this stream while observing through your own optical instrument, be it a telescope or powerful binoculars. There is NASA Eyes on the Solar System. That's a really good one, which I'll come back to because I'll actually load this up. But if you just search NASA Eyes or NASA Eyes on the Solar System, you can download it for Mac, PC, and mobile devices. You can download the app right there. And I'll show you what that looks like in just a second. But the other one I want to show you is all web-based. This is Mars Trek. And Mars Trek is an extremely high-resolution detailed map of Mars using the satellites that are in orbit around the red planet. And it actually takes a while to load the data in. You can just keep on zooming in and it'll load up in different blocks because the data you collected is so... there we go. Finally snapped into view. You can just keep going. Why is this still... Let me turn this on silent mode. There we go. I have it on Do Not Disturb, but it's still disturbing me. I don't know why. So that is what we'll use tonight to look for some features of Mars, depending on how much detail we get. This is Val Marineris right here. It's the huge, almost like a crack in the Mars surface. In fact, this is the width of the United States. And we probably won't get enough detail to see that tonight. I'm not even sure if it's facing us. It might be. But these dark patches and potentially the South Pole, we will potentially see those. But the dark patches are going to be the most detailed. Like this feature here is called Syrtis Major. That's one of the features we want to spot. And it's very easy to see it because it's sort of like this L shape. Okay. So that's Mars Trek. You can search for that and look at maps of Mars. Now NASA Eyes on the Solar System, I'm going to load up right here. Not authorized to send. Okay. That's fine. I don't need you to. Does it really not want to load? I think it's trying to load. Let's see here. There we go. Not sure what that was about. So, let's see. I want to go to eyes on the solar system. We'll just keep it simple for now. The reason I'm going to show you this is because this gives you a great layout of the solar system. And I want to show you why last week on October 6th, I believe, we were 36 million miles away. And now tonight, we are about 38, 39 million miles away. Even though we're at opposition, I want to show you why that's the case. The reason I did not have this loaded up beforehand is because if I leave these things open for too long, I'll bog down my computer. So I want to avoid that if I can. So we'll let this load up. Oh no, I have the rainbow circle. Infinite rainbow circle, oh no. If for whatever reason the video cuts out here, just stay in the live stream. I'll be able to reboot the stream in the same link, within the same link. So don't worry about that. There's been some cases where I bogged down my computer enough it just didn't want to work. But
welcome to Eyes on the Solar System,
yes.
where you can explore your planetary neighborhood.
So you see how it's loading in the orbits of the planets. We're going to go into the inner planets. That's where we're focused tonight. Jupiter and Saturn are out in the sky, but we'll still have plenty of time to observe those in another stream. So we're focused on Mars tonight while it's nice and close. So I want to bring up these so I can adjust the times. I want to go to now. And we're going to zoom in even a little bit more. Frame rate is kind of dropping. But do you see this right here? We have Earth, Mars, and the Sun all lined up. Now, I'm not going to mess with the timing too much. I think this is going to get the idea across well enough. But do you see how the orbits aren't perfect circles, and they're also not necessarily concentric circles, meaning the circles are equidistantly spaced? That's why last week we were really close to Mars, because you can see our orbit kind of breaks in here towards Mars, and there's a point where you're closer in this range than you are right now. So that's why the opposition isn't necessarily the closest point, but it is still a great time to observe because we are right on top of it, basically. But if you saw a lot of stuff in the news last week about, oh, this is the closest we'll be until, I think it was like until 2035, that's why. But even over the next week, 2 weeks, 3 weeks, it's still going to be perfectly fine, if not even after that, into a couple months. Mars is still going to be nice and bright and great to observe. So, let's see here. Okay, so I'm going to exit out of this before it shuts down my stream somehow, because I can feel the fans revving up. Okay, so that's NASA Eyes on the Solar System. It'll work great if you're not running a streaming software in the background. But that's officially put out by the Jet Propulsion Laboratory. Okay. Last thing I want to show you is where Mars is situated in the sky, so you can find it yourself if you have clear skies in your area. And then I promise we'll get to observing. So this is a program called Stellarium. You can see the website right in here. Stellarium.org is where you can go to download this software. And it's a planetarium program you can run at home. So if I zoom out here, you can get a sense of things. You can even look at the sky in its entirety if we sort of point our sky up and zoom out. This is a 360-degree view of the sky. You can see the cardinal directions, compass directions, all around the horizon, where the ground meets the sky. And like I said, you can see Jupiter and Saturn here, almost due south at this time. This is present time. Actually, it looks like there might be a bit of a daylight savings time issue, so we might be an hour behind, but that's okay. It'll be roughly the same. Oh, why don't I just bump it up an hour? Oh, there we go. So Jupiter and Saturn, south-southwest looks like right now. And the Milky Way is southwest. That's our galaxy. And we can pan over here into the eastern sky because Mars just rose up, as I said earlier. I was just catching it as it got above our tree line here. So here's Mars. And it's a magnitude, according to Stellarium, it's a magnitude negative 2.62, which is really bright. Negative numbers are bright. Like we can compare to Jupiter here, which Jupiter should be a bit brighter, I think. Let's see what it says. Oh, wow, no. Negative 2.27. I already forgot what Mars was. Negative 2.26. No, 62. So Mars is actually brighter than Jupiter tonight, it looks like. So that's pretty neat. So, there we go. We can also zoom into the red planet. So before I do that, you're going to want to look right now towards the eastern sky, and you'll see a bright red spot, bright star. It's not even... You'll notice it's different from the stars. The best way to tell the difference between stars and planets is planets do not twinkle. They are pretty steady light. So stars are, their light is far enough away that once it all travels light years through space and then hits our atmosphere, the light is destabilizes isn't the right word, but that's how you can think of it. And you'll see a twinkle effect on the stars. So if we zoom in here, you'll see the red planet. And you'll also see that there are moons, Phobos and Deimos. We can even travel through time and see those moons orbiting around Mars. Phobos and Deimos are just captured asteroids. I don't think we're going to be able to see them tonight with our telescope, which I'll show you in just a moment. But Phobos is closer to Mars. Someday it will crash into Mars. But don't worry, it's a ways off. So if you want to travel to Mars, don't let that stop you. Deimos is further out, and I don't think Deimos is in a decaying orbit necessarily. So those are tiny little objects. Not easy. Oh, we're already going to the morning sky. So that's Stellarium, great tool for astronomy. So if you want to explore the sky yourself, there's also a lot of good smartphone apps. I think even Stellarium has a smartphone app you can use. All right, that's enough of the astronomy tools. That's what I'll be using tonight to help me out. And you can follow along and explore yourself if you like. All right, one thing I'm going to do, I'm going to turn on the white lights temporarily. And I'm going to show you the telescope we have, just because I think we have a lot of new people joining us tonight. There's quite a few viewers. So before I get to questions in the chat and we start observing Mars, let me show you the scope we're working with tonight. Oh, white lights aren't working. I gotta flip the switch down below. Give me 1 second. There we go. Okay. I'm going to switch to the other camera here so I can show you the scope. Camera 2. There we go. So you can see, there we go. This is the 6-inch refractor. It's a really long telescope. It's a focal ratio f12. And it's great for observing the planets. It's a 6-inch refractor, so that means it uses a 6-inch diameter lens. And it's great for observing those bright planets like Jupiter, Saturn, and Mars. Now we have, you can see this cord over here, connected to that red cylinder in the eyepiece area. That is the camera we're using tonight. You can think of it like a specialized astrophotography web camera, and that's going to be delivering the image to you virtually. And you can see the dome here as well. Telescope's pointed right out that dome into the darkness of space. So I'll be moving that dome periodically throughout the program as Mars moves through the sky. Okay, let's go back to observing screen. Oh, computer screen. Oh, spoilers. Oh no. So I meant to go to the computer screen, not the observing screen. So I think, why don't we just get started with our Mars observing. As I said, the sky will improve throughout the night, so stay tuned for that. Check in, chat with our fellow observers in the live chat. I'll be here to answer questions, like I said, and provide some commentary throughout the program. Okay. Also, if you are in a position to do so, there is a link in the video description where you can support our stream. It's a Streamlabs link, and we would greatly appreciate any support you can provide us through that, or if you can support us through a subscription or liking the video, that would help us out too. So let me turn the white lights off. Okay. Let's go to the observing screen, and I'll get a full screen view of that, and I'll explain what we're looking at. Oh, you know what? My mouse isn't picking that up. Hang on. Let me go back here. I want to make sure you can see my mouse so I can point things out on Mars. So if we do that, yeah, that looks good. And I'll adjust the field of view here. There we go. So there is Mars. Now, as I said, we are still sort of peering through the more of the atmosphere than we will an hour or two from now, where it gets higher up in the sky. So if you see, I know someone asked in the chat here, Tasha, what in the atmosphere causes good and bad seeing? Here's an example of what poor seeing can do to your image. It's not terrible. I think this is a little bit better than, at least better at this time on Friday. So the comparison, I think, is a little better here. But you can see the image of Mars here is not a perfect circle, right? You see how the edges warp and move? So the reason for that is because of the turbulence in our atmosphere. And that turbulence is, you can think of think of it in terms of movements in the air. So if you think of temperature gradients and temperature disturbances, like even if you're just out on a run on a hot summer day and you see almost like the heat rising off the pavement, that's effectively what we're working with, except on a large atmospheric scale, where you're peering through the entire thickness of our atmosphere rather than just a short distance. So those small or even large fluctuations in our layers of atmosphere cause this turbulence and the warping of the image that you see here. Now, like I said, there's multiple factors at play here. So once we're looking through less of the atmosphere, that's a good sign that we'll see improvement. And according to the clear sky chart, it said that we should expect the skies to improve as the night goes on. So I think our seeing will improve as it rises up and as it gets later into the evening. Okay, good question. Hi, Michelle. Yes, yeah, it is looking like a pretty good evening. definitely better transparency tonight. I was able to see the Milky Way far better, and I'm seeing way more stars. Also, the wind I don't think is going to be as much of a problem tonight, which is great because that really affected any chance of collecting any good data for a final image, processing a final image of Mars. So that's why we didn't share any yet on Facebook. Usually after these observing streams, I go through, take the data that we collected, and process an image. I wasn't super happy with what I was seeing so far, and I thought maybe tonight, with less wind and potentially better seeing, we'll have better luck and get a better collection of data. So we'll be on the lookout for that. Also, coming up in the stream, we are going to improve our view of Mars by increasing the magnification with a Barlow lens. So we're going to increase the magnification by 2. In fact, if I show you here, let me show you what it looks like at 100%, meaning it's not digitally zoomed at all. That's 100% crop. So this is what Mars looks like if you were to look through a pretty high-powered eyepiece directly through the telescope. We're going to be able to magnify this 2 times, potentially collect more detail, and we'll be able to digitally zoom even more and maybe see some more stuff on the surface. Now, Mars is great because it's really one of the main planets, the terrestrial planets, meaning rocky worlds, that we can see detail on the surface of. Like Saturn and Jupiter, you can make out some detail, but those are gas giants. Earth is easy, right? You can definitely make detail out on Earth. Venus, you can't see anything on the surface through regular telescopes because the atmosphere is filled with clouds. So you don't get to see any detail there. The coolest part about Venus is, one, just how bright it is. If you see it, it's either the evening star or the morning star, but of course it's a planet. It shines so brightly, especially when we're near opposition with Venus. Or I guess Venus is near opposition with us. So that's a great object to look at with just your eye, just based on how bright it is alone. Mercury is also just so far enough away and pretty small that regular telescopes can't see much detail on it either, even though it's similar to the moon as far as its surface. There's no atmosphere. It's just cratered, much like the moon, but it's just so far away and so close to the sun that the light that reflects off of it is already way overexposed compared to light hitting Venus, Earth, Mars, and so on. So that's what we have going for Mars, is that we can actually make out detail on the surface. It does have an atmosphere, but it's way thinner than ours and way thinner than the Venus atmosphere. So the surface detail is noticeable. On the best of nights, when you capture a bunch of images and stack them, you might even be able to make out some of the larger clouds. Hubble definitely can. The Hubble Space Telescope has no problem resolving that detail. So Mars does have clouds, not nearly as thick or as many as Earth's, but it does have a cloud system. I believe when I looked at some astrophotos that people were taking during this opposition, the type of clouds you see are often on the edge, where you're peering through more of the atmosphere, so you have a greater chance of spotting those cloud layers, which might be pretty thin when you're looking looking top down on them, but when you look at them from the side, you might be looking through more thicker layers. So I think I noticed that in some of their images. Now, to give you an idea of where North and South are, the North Pole and South Pole, just like Earth has North Pole and South Pole, so does Mars. We can go over here, and I believe, we saw that dark, almost patch across the equator of Mars. So this is a good indicator of where the equator is. So I believe the South Pole should be right in here. So as the night goes on, and you might even see it, it's hard to tell if we're seeing it yet, you might see a white patch pop up right in there, and that's one of the polar ice caps. It's the southern polar ice cap. The northern polar ice cap is not visible to us right now, but the South Pole is. Just like the Earth goes through seasons, so does Mars. So it actually will tilt back and forth as it orbits the sun. And just like we'll have 24 hours of darkness at our North Pole sometimes, that's the same thing with Mars, is it can have 24 hours of darkness at its North Pole. In that sense, Mars is kind of similar to Earth. In fact, Mars has just over 24-hour days. It's actually 24 hours plus a half hour. So that's kind of convenient, right? If you're traveling to Mars, you don't have to adjust your sleep schedule too much if you build up a colony there. But the jet lag is pretty severe, I'd imagine, flying there. So the days are pretty much the same once you get on the surface as far as the timing goes. But of course, you do have to worry about surviving, and the atmosphere, like I said, is very thin. It's also toxic. It's mostly carbon dioxide, and that's no good to us, right? For respiration. So we can't breathe on Mars without bringing our own oxygen, or we can make it on the surface, or recycle the carbon dioxide that comes out of us, but also there's carbon dioxide on Mars, so that's possible. Let me get the mouse off the planet there. So, there we go. What else about Mars as far as trying to survive there? It does get pretty cold on Mars. During the winter time, you can drop below negative 200 degrees Fahrenheit. But during the summer, the temperature readings can reach about 70 degrees Fahrenheit, which isn't too bad, right? Of course, the atmosphere is much lower density, not as thick, so it will still feel colder. But 70 degrees sounds pretty good, right? I'd be okay with that on a Martian summer, even if it felt a little bit colder than it is. So either way, though, you do have to bring your own climate control system. Furthermore, Mars is effectively a dead planet. The interior of Mars is not nearly as stable, or not stable, wrong word. It's not nearly as active as Earth's. A lot of it has cooled down, unlike our planet, which still has plenty of energy and radioactive elements inside it to keep our core warm, exceedingly warm, and that's a big difference between them. Is Mars has already cooled down, which means its geological activity is very minimal. They did just send what year was that? It might have been 2019, 2018 or 2019. They sent the Mars InSight lander. Now the lander is different from a rover, of course. Here, let me go ahead and center Mars a little better here for us. Oops. So what I'm doing right now is I'm using, you can see this little hand paddle, which lets me control the motors on the telescope. And the motors are keeping track of Mars for us as our Earth rotates. Mars is going to appear to move across the sky, and we have to keep track of that movement. That's what this mount on the scope can do. It can't find objects. It's not a go-to mount, but our other telescopes are. Other two dome scopes, the 14-inch Celestron Edge HD reflector is a go-to telescope, as well as our 20-inch reflector scope, which is our flagship here at Kopernik. Okay. Let's see, where was I as far... I want to check the chat here, make sure I'm not missing any questions. Again, I welcome you to ask any questions you have about Mars. That's what I'm here for. I'm a Kopernik educator here at Kopernik Observatory and Science Center. We are located in Vestal, New York, and we are sharing this live view of Mars across the internet for anyone to view. Which is great, because if you have cloudy skies in your area, or if you do have clear skies, but you just want to chat as we all share this opposition together, then that's what we want to offer to our viewers. So if you like what we're doing and you're new to the channel, consider subscribing. Oh yeah, good point. Let's see how the dome is doing. Oh, yep, looks like we did. We hit the dome. So that noise you just heard was me rotating the dome. And you see that Mars is now brighter. Good catch there. Let's see. I want to try adjusting the focus a bit just to see if we can get some more clarity. Now that we have a little bit brighter image here, let me go ahead and just bring down the exposure just a bit, because we were a little bit overexposed in the brighter parts of Mars. I'll go back to full screen here. Now, occasionally the image looks like it gets hung up for some reason, and I'm not sure why that is. That wasn't happening on Friday. So at some point I might try rebooting the software that's running the camera, and we'll see if we can get that stutter, mitigate that. But let's try and adjust the focus. I'm going to zoom in just a bit more here. A little bit later we will try the Barlow lens as Mars gets higher up in the sky, and we lose some of that turbulence that you're seeing there around the edges. Let's try focusing. See if we can get any more clarity. So that's out of focus. Let's ease back in here. That's not awful. See, the tricky thing is when the atmosphere is turbulent like this, it'll come in and out of focus at different points, even in the telescope. So as you adjust focus, you might get a nice clarity level on it, but then it'll go out of focus again because the atmosphere is so crazy. But I do think this is better than last week, and especially with no wind, or at least not very significant wind, we will do better as the night goes on. Oh, here's a fun question from Michelle. So you can go to Mars, but you cannot return to Earth. Would you go? I think for me it really does depend. I'm probably not known for being a risk taker. So, or at least a big risk taker. It's just not, for a while growing up, I was like, ooh, astronaut sounds fun. But then as I grew older, it just doesn't seem to mesh with my biology, I guess. So not that I would object to going into space by any means. I would love to explore space in person and fly out there amongst the stars. But that does come with a caveat of I don't know if I would like to go to Mars and live there unless we had a good sustainable colony system there. And not that it had to be like terraformed, like it was basically the Earth at that point. No, I would be interested in going there if it was just a colony similar to what you see in some more realistic sci-fi films. Something like the Martian comes to mind. That movie and book. That might appeal to some degree. Although I wouldn't want to get stuck there like he did. Alone. Maybe that's not a good example, I don't know. But no, I would consider it. Good question. Now, if you think into the far off future, where maybe we figured out space travel, be it interstellar or even just quicker interplanetary travel, then you're really talking, because then you start really getting into the fun sci-fi elements to think about exploring great new worlds where the focus is less about 100% not so much focused on just getting there and surviving and making sure you land on the surface and everything is a risk. You lower the risk level so you can just focus on the science of it all. That'd be great. Good questions, everyone. Yeah, I think we have potentially some new viewers tuning in this evening, so I'd like to welcome you to our channel. I'm just seeing the viewer count go up and down a little bit, so I'm assuming we have some new people. So welcome to our observing stream. We're observing Mars through our 6-inch refractor telescope, and the clarity should improve as the night goes on. So feel free to check back in every so often, see if our view has improved. I will eventually push the magnification even more than we're at right now with a Barlow lens that'll push us in two times greater magnification. But we host programs like this at Kopernik. We're located in Vestal, New York. We're hosting programs like this all the time. And if you want to see more like it, hit that subscribe button and tune in for our future streams, which we'll explore deep sky objects like the Orion Nebula is going to be rising earlier and earlier as we head into winter. So I'm excited to observe that one, even though it's going to be cold, but that's okay. It's not too bad tonight. I did decide to put a coat on compared to the previous streams where I didn't feel like I super needed one. But it's getting to that point in the fall here where it's becoming necessary. But I still plan to keep going. I don't mind it being a little bit cold. I can always run inside and warm up. Our observatories are not heated like most because that would affect the optics, the actual visibility of the objects. Again, going back to that idea where you're it's a hot, sunny day and you're looking at the pavement and you're seeing that heat rise off, almost like a wave. That's what you want to avoid in a telescope, is you don't want to add more atmospheric disturbance than there already is. So we have to avoid that. So it will be the same temperature as it is outside. And sometimes the air is so still in the domes. I don't know, there's something about that where it sometimes feels colder. Even though like when very cold air is hitting you in the face, that is much worse, of course. But I don't know, there's something about the still air. And it's also the conductivity of the metal. So it's all that convection and conduction coming into play there. Let's see. The chat is open. Where does that go? Okay, there we go. Let's see. Going back to the chat here to answer any questions. Got someone from Katie from Lancaster, PA. Welcome. Yeah, Patricia. It is super bright in the sky. It's even brighter than Jupiter from what we saw in Stellarium, and it's just a fantastic view even just to see with your eye, because you can definitely notice the color of Mars, especially when it's low in the closer to the horizon as it's just rising. But you can still see the color as it rises up in the sky. If I go look here, yeah, it's still a nice dull red, a nice dull rusty color. So a really good view we're seeing, both with just your eye and through a telescope like we have here. Yeah, great views. I'm glad. It sounds like a lot of people are able to spot it, so I'm glad so many people have some clear skies. Tasha, have they released any updated plans for the colonization of Mars? I went to the presentation about that a while ago at Kopernik. So right now, NASA at least seems to be pretty focused on sort of the transition mission going back to the moon with the Artemis program, which should lead to the first woman landing on the moon, which is incredibly exciting. And I think a bunch of countries just signed on to that, which is also exciting. So it's always good when it becomes an international effort. Just like the International Space Station, I think that was an incredible project. The Artemis program hopefully will become something similar. Where was I going with this train of thought? So as far as Mars goes, I mean, with SpaceX coming into play here, I mean, they have their own aspirations to go to Mars privately, independent of NASA. But of course, SpaceX is also partnering with NASA to send astronauts to the International Space Station. Douglas Hurley and Bob Behnken just did that over let's see, I think it was May. They launched with the Demo 2 Crew Dragon mission, and they came back in August 2nd, if I remember correctly. So that was a successful mission, and now they're doing the first actual official mission with Crew Dragon. I think they moved it out into November now. It's supposed to be in October. But that's exciting as well. So the partnership between SpaceX and NASA could continue to grow, and perhaps they end up going there together in some capacity. Mars is always in the plans, and I still foresee maybe in the next decade, as we head into towards 2030, hopefully within the 2030s, we will end up on a Mars mission there and sending humans there. It's always been the prediction and the hope, but it is a great engineering challenge, far greater than going to the moon, and that's why they are using that sort of as a jumping off point. Get back into the swing of things, so to speak. So no firm plans yet, but the scientists across the world are always working on it. So stay tuned. Of course, the Mars Perseverance rover just launched in July 31st. In fact, you'll find that missions to Mars often launch a couple months before, a few months really, before opposition. And that's because it's a great opportunity. If you remember when we were looking at the orbits of Earth and Mars, Earth is of course going to move around the sun faster because it has a shorter orbit, a smaller orbit around the sun. It's closer. So it's going to be able to catch up to Mars. And you can sort of use that momentum, right? And launch from the Earth towards Mars. So you do that a few months before you get to opposition when you're right in line with it. Because then you have to fight going against the momentum of the Earth's movement. And it doesn't end up being practical. So it makes more sense physically to use the momentum of the Earth as it's orbiting around the sun and use it as a jumping off point to get to Mars. So that's why Perseverance launched back in July 31st. And we held a watch party for that on our channel. And we got to see it successfully launch and head towards Mars. So it'll get there February, I think we checked it last time. I think it was February 18th. I know it's February though. And that'll be very exciting. The Curiosity lander, which is sort of a twin, Curiosity rover, which is sort of a twin of the Perseverance rover, is already there. It landed in 2012, and it's been a greatly successful mission. It's still roving around on the planet. Definitely weathered a bit. Its wheels are in a little rough shape, but they improved upon the wheels this time, so hopefully those won't get as easily damaged. But it's still working fine, and I think it still has plenty of nuclear energy to run off of for a little while yet. It's not powered by solar panels like the previous Mars rovers. It is powered by a nuclear battery. You can think Back to the Future, right? They had to power it with plutonium. So similar idea there. It's radioactively powered. And that's going to be exciting for another huge car-sized rover to land on Mars. What a feat of engineering to do that alone. And it's just going to show that later on, we're building up these skills. Like, consider what we landed on Mars in the first place. With landers that didn't move around on the surface at all, to the Sojourner rover. Sojourner, right? I think so. Is a little RC car-sized rover. It was really just to test if you could get a rover there, and drive it around on the surface. That worked out. And then Opportunity and Spirit rovers, which were much smaller than Perseverance and Curiosity, but they were laboratories, smaller laboratories on the surface, but they performed a bunch of important scientific discoveries. And those, unfortunately, are both decommissioned. They're still there, but Spirit was lost, I think, in 2009, and both of them landed there in 2004. They were twin rovers as well. And Opportunity was lost in what year was it? It was pretty recent, comparatively, to Spirit. But just considering the fact that they were actually, I feel like it was only within the last few years that we lost Opportunity. Let me know in the chat if you remember when that was, that we lost communication with Opportunity. But yeah, they lasted so long. They were only really scheduled to last 3 months, and looking like they're lasting years. It's incredible. So hopefully Curiosity will still be kicking once Perseverance is there and they can explore Mars, different locations together. Let's see. Oh, is my volume a little bit low? Here, let me adjust that a little bit. I can. Those of you that are maxing your volume, you might want to lower it as I do this because I'm going to turn it up. I don't want to. There we go. So you might need to lower your volume here because it might peak some of your speakers. But hopefully that helps those that aren't quite hearing it as well. Let me see here. Going back to some questions. We went down a deep rabbit hole there. But that's good. Oh, Baloo, thanks for the update and reminding me about the Orionids. We'll get on that for sure. I should be able to make those times work, or those dates rather. We did the Perseid meteor shower stream back in August. Over a few days, we had a few separate streams, and that was really successful. We saw quite a few bright ones. So I'll use a similar method that I used for that stream. Let's see. Yeah, I think we'll a lot of you will see Mars, or at least humans going to. You can see Mars, of course. At least humans going to Mars, in the next, hopefully, the next decade to 15 years. Again, it's a challenge, but these engineers are hyper intelligent. I think they can do it. Oh yes, Blue. I wish we could have everyone come up here and observe directly through our scopes. And I hope it's sooner rather than later that we can continue that. The nice part though is that for those that aren't from this area and are observing over these live streams with us, this probably isn't going anywhere. I'd like to continue to do it as even as things open up in the future again. But yeah, I definitely, for those that are local or want to visit us someday in Vestal, New York, then yeah, hopefully we'll be able to open at some point for that. Yeah, they're pretty close in brightness, Atul. As far as the brightness of Mars and Jupiter, pretty close. Oh, is that true, Michelle? The car passed by Mars recently? I didn't know that. I know you can track it. I haven't been looking though. That's funny. Thank you, AstroZoe, for the update on Opportunity. That's exactly what I was looking for. 2018 mission ended. They stopped trying to contact February 13th of 2019. Yeah, it really wasn't like oh, that's right, 14 years. Yeah. Okay, that's the number I remember having in my head, and I lost. 14 years. Because I was going to say at first, before I stopped myself because I didn't think it was right, I was going to say 2014 because I had the number 14. But I was like, no, it's 14 years that Opportunity was there and performing its mission on Mars. It's still there, of course. Buried in the Martian sands. Not completely buried, but I'm sure it's pretty dust covered at this point because that was part of the problem they were having is the big dust storm that came by during the last opposition. That was July of 2018 was the last opposition. The opposition to Mars usually occurs. It should occur about every 26 months. So the opposition was just a bust. As far as imaging goes, this is way better because there was a huge global dust storm, completely ruined any opportunity to do some good imaging. You can think of it basically as Venus. Occasionally that does happen, where you just get a massive dust storm, blocks out a bunch of detail across the planet. Not the case this time, though. We're lucky. But that's what ultimately ended Opportunity's mission. Just couldn't survive that dust storm. The hope was, if I remember correctly, the hope was that the winds of Mars would blow off the panels over time, and they'd eventually charge Opportunity up enough to send a signal back to NASA. It didn't pan out, though. They kept trying, just didn't work. Wouldn't it be amazing, though, if one day you just hear, it's like a movie, right? You just get this ping. It's like, it's Opportunity. So, John, you can definitely give it a go with your binoculars. Usually you need pretty powerful ones to really make out any potential detail, but it's worth a try. Everything's always worth a try, and at least with the binoculars, you should be able to notice during the opposition that it's more than a point of light, like a star. Like if you look at a star through your binoculars and then you look back to Mars, you should be able to see that it is a planetary disk rather than just a regular old point of light star. Oh yes, Stacy, yes. An 11-year-old son who wants to be the first human on Mars. Yes, they're the generation that I think are our biggest promise of visiting the red planet. So that's great. I'm glad to hear he's eager to get there. Oh wow, Tasha, that's great. Traveling to Africa. Yeah, that is true. You might have you should have clearer skies. And yeah, hopefully we'll be continuing these live streams too. It'd be great to hear from you a year or so from now, and as we're still doing these and hear about your observations there. Okay. Now, do we want to try boosting the magnification? Let me know if you think it's time. I think it's still a little bit wibbly wobbly, but I think maybe boosting it could give us a little bit more detail potentially, and we won't have to use digital zoom as much. We can increase the zoom optically and hopefully get some more detail. Because again, this is what it looks like. Zooming out here. That's what it looks like right at, one more step. 100% crops. This is like if you were looking through the telescope with a high power eyepiece. We can push it even a little bit further than that. So I think it might be time to try that out. You will have to bear with me while we switch to a different eyepiece. Let me see if I can add in just for anyone that tunes in. I'm curious if I can just add in some text here. to our stream, an overlay. And again, if you are enjoying the stream, please hit that like button. And if you're new to our channel, consider subscribing. We would love to have you for future programs. We'll be observing deep sky objects in the future, Jupiter, Saturn, bunch of different objects. We're focused on the opposition tonight just because it's a big event, right? But in the future, we'll do even more. There we go. All right. Okay. I want to add in one more thing. Stay tuned. There we go. Just in case if anyone comes along. All right, so I'm going to switch the magnification to a higher power. Yeah, I'm just about to switch to the Barlow lens. Right now we're just using the just the camera alone through the scope. So we'll add a Barlow lens in and zoom in a bit more. So bear with me here while I adjust our view. I'm hoping as the night goes on and as Mars even continues to climb up in the sky, and as I said, seeing is supposed to improve as the night goes on, hopefully our view will improve as well. So we'll see what happens, but I'm going to switch to the Barlow and we'll go from there. I'm going to turn the lights on for a moment so you can see what I'm doing. I'm going to finally take the diagonal out. I always leave it in, I forget not to. So if you can see, you should be able to see roughly what I'm doing here. This is a right angle mirror that sort of projects the light coming through the telescope to a more comfortable angle for observing. We don't need that for the camera though, so I'm going to take that out. I just had it in there, so I forgot about it. This though, I'll show you here. This is the Barlow lens, and we're going to hook that up to the camera, and it's a 2 times Barlow lens, so it's going to push our magnification 2 times. Zoom in 2 times. So we're going to put it in between, the Barlow lens goes in between the scope and the camera. Okay, I think we're good to go. I am going to move the dome over a little bit. I will need to adjust our view, so let me turn, well, first thing I want to do is move the ladder a little bit out of the way so that the telescope doesn't crash into it. Because the telescope is moving, just very slowly. The reason for that is because it needs to follow the rotation of the Earth. Because the sky is going to appear to move as the night goes on. And there's also subtle movements like the orbit of the Earth and Mars that are far less significant over an evening compared to the rotation of the Earth. So really, the biggest thing you want to track is the Earth's rotation. So now that we have the Garlow in there, I will have to work on getting Mars back into the center. But I have a pretty good process for that. It shouldn't be too difficult. Let's see, I should zoom out if I can. There's 80% crop. Let's see. Oh, we are right on top of it. We're actually looking at a very unfocused view of Mars right now. I think. Yeah, you see how it gets brighter as I pull the focus out? Mars is going to start to get smaller. I can roughly center it here. See how it looks. If we lower the gain. Whoops, too far. Almost there. There we go. Make sure I don't trip on any of these cords. Might need to. I think we're too far. Maybe a little bit more give. You know what? At right angle, I might have to use anyways. Just to give myself a little bit more focal length to get Mars focused for us. Something's loose here. That's what's loose. And that's what's loose. Go. So I am adding the right angle back in just because I need a little bit more length to focus our image. For the purposes of the stream, that should be fine. There it is. Again, we're super unfocused there. So we're going to bring camera back in. Okay, just about there. There it is. So now we have a little bit more of optical zoom to play with. Now, the seeing does prevent us from still making out some of that detail that we do want to see. But again, as the seeing improves, we'll be able to hopefully make out more and more of that. Hopefully get the south pole nice and clear. Now, every so often, you'll see the image pop into a nice clear view. And that's what we want to notice. Now, when we're processing this data, speaking of, I should really start recording some data. Maybe I'm really waiting for it to improve a bit before I do that, though. But to talk a little bit, let me turn the lights down. Go back to reds. Red lighting is good for astronomy, keeps your night vision. When we're processing images, we record a video, so we collect a bunch of different frames from what we're seeing here in our live view. Oh, there's a little bit of a defect on the lens there. There we go, let's get away from that. Unfortunately, that defect is right in the center. Oh, let me get rid of this switching magnification. I don't need that anymore. It's a handy little object, though, that I might use later. So, where was I? My train of thought. Oh yeah. So when you record a video, basically what you're seeing here, you can take each frame that shows up as a nice clear view where that detail on the dark bands of Mars and maybe the South Pole pops up. That's all the detail you want. In those moments, those frames each of those frames have separate sets of clear information. And you can stack those separate images to develop a really nice process view of Mars. You basically stack each set of details on top of each other, and you pull different details out between each frame to make a higher clarity image. And it's all real data. It's not like you're cheating. You're just using the most valuable data in each frame. Let me see, I gotta check my backlog of questions here. It does look like a bouncy ball. Tasha, another good question. She says, I saw that Mars has the tallest mountains in the solar system. Does Mars have a similar system of plate tectonics like Earth? Yes, Mars does have the tallest mountain and largest volcano in the solar system. That is Olympus Mons. It's a massive and now extinct volcano on Mars. As far as plate tectonics go, I feel like I've read about that before, but any specific information escapes me, so I don't want to really wave my hands too much about it. And I mean, if you think about how Mars was once much more like Earth, it was had a very active inner core that has since cooled off. It would make some sense that it should have active plates if there is an active surface underneath. So like a mantle, right? That's what our plates, our continental plates are shifting upon, is that liquid surface. Oh, something moved. Hang on, let me check. It shifted. Make sure everything's okay. I think it is. Okay. But it would make some sense if it did have a similar mantle. I mean, Olympus Mons is that volcano, right? So, let me recenter our planet for you. So, yeah, I think there's probably some truth to the idea of Martian plate tectonics. Mars is still mildly active as far as its interior goes, and as I mentioned earlier, the InSight lander is there looking for it's there to observe the interior of Mars, figure out exactly what it's like now, and it's also there to study Mars quakes. You can't call them earthquakes, right? They're Mars quakes. So, yeah. So there is some activity there still, but as far as a sophisticated system of plate tectonics, I don't know enough about it, unfortunately. That's just I waved my hands anyways, didn't I? Oh, Disham says, our students in class I work in are doing reports on planets to present this Friday. That's exciting. I remember in school, that was probably one of my favorite opportunities when, be it later in middle school in earth science or in elementary school when you got to focus on the planets. Oh, that was so awesome. I can't quite remember which one I did, which one I focused on. It might have been Mars, but it also might have been, even though it's not a main planet, it might have been Pluto, because I do vividly remember back in let's see, it's probably 2005. I remember reading, and that would have been in 5th grade, I think. I remember reading about the New Horizons spacecraft that was flying to Pluto, because it took, or going to fly to Pluto, because it launched in 2006 and got there in 2015, I believe. So I remember reading about that, and that was just super exciting because I knew there wasn't any good images of Pluto. It's just so far away and too small. So we didn't have really good data on it at all. And just to see that finally come to fruition 9 years, I guess it would have been 10 years later, from when I read that article. And I think it was in I don't know if they still make them, but I think it was like, what was it called? Times for Kids or something like that. And I read that, and 10 years later I got to see it come to fruition. It was incredible. So mine might have been Pluto, but yeah, those are fun projects. So that's exciting. I'm glad to hear about students studying and exploring space. Tasha. So yeah, those, if we pan over down to this really bad one right here. Yeah, that's just some something in the optics of the scope. It might be in the Barlow, although I tried cleaning the Barlow out a little bit. So I cleaned the camera a little bit as well. So I don't know exactly where that is, but yeah, it's dust. It's a little speck on a lens somewhere. So I just gotta avoid them, because I definitely don't want that in image data. You can see how it's sort of out of focus, so that gives you a good hint as to where it is when it's out of focus like that. So it's not at infinite focus. It's something closer. I have a question, everyone. Is your video feed lagging a little bit at all? I noticed it as I watched the stream here. I noticed it as the banner came across the screen. It looked like it might have been stuttering. Let's see, it's coming up again. Let's see if it does it again. Oh no, it looks smooth again. I don't know what that was. A hiccup in the stream, I guess. It did for a few seconds. Okay. Well, we'll keep an eye on it and see if I can... Yeah, see, there it goes again. I'll do my best to keep an eye on it and make sure it doesn't become a huge problem. Let me see if I have anything open that I can get rid of. No, it's really just... Well, I can get rid of... Let's just close out right here. Yeah. I probably won't do much, but the map actually does take up a little bit of resources, so that might smooth things out a little bit. We'll see. Get rid of that defect. Down there looks pretty good. Oh, good. So, all right. I'm glad it was time for kids. Yeah. Science for kids. Yeah. Okay. So that's good. I'm glad it's still around. I don't know why it wouldn't be. I'm not that old. I don't think. All right. And if there's anyone new joining us tonight, I welcome you to our stream. Consider subscribing to our channel if you're interested in other observing programs here at Kopernik. We continue to stream things like this to you from the Mars opposition, which is a big event happening right now. It's actually tonight is the opposition. And to deep sky objects, which is really what I want to focus on next while we have a new moon. Maybe in the next week I'll try and do a deep sky stream if the weather behaves. Deep sky objects are like nebulae and galaxies and star clusters, so I do want to try that. And there's also Saturn and Jupiter are out right now, and probably not for too much longer. But those are great planets to observe too this time of year. And in December, there's going to be a conjunction. I know this is I sound like a broken record to our regular viewers, but I really want to push that conjunction because if everything pans out, the coolest part about that is in a wide field of view, you'll be able to make out detail on Saturn and Jupiter through one field of view, so one telescope view or binocular view. So you'll be able to see the rings of Saturn and the moons of Jupiter all in one go. So that'll be incredible if we can get that to work out. I'll probably have to use my... this camera won't work for that. This will probably be too narrow a field of view, too zoomed in. So I'll probably have to use the mirrorless camera for that. Get a little bit of a wider shot. Maybe put a Barlow on it, like we did with the moon on the 26th. Let's see if we can play with the focus again. If we can improve things any. That darker patch is showing up a little bit better, I think. If we do that. And maybe... keep an eye out, again, like I said right here. This is another patch of darker gradient on Mars, right in here. That's coming in every so often. It's not as high contrast, so only when the seeing clears up every so often do you see that. But go even further, and at the very tip here, try and see if you can spot one of the poles of Mars. This would be the South Pole. The North Pole is invisible to us right now. It's actually shadowed. Just like it's actually, you could think of that as winter on Mars in the North Pole. The southern hemisphere should be summer. So 24 hours of darkness, not 24 hours, 24/7 darkness during the winter there on the North Pole, and then it's nice and sunny here in the South Pole. Just like here on Earth during summer and winter, the changing seasons. But you're looking for a little white speck there. I'm not sure if I've seen it officially yet. We saw it last week. It came into view a couple times. But tonight I'm not sure so far. Now, if there ends up being a really good seeing at some point during over the course of October, really, like I said, Mars is going to be nice and bright and big in telescopes, as big as it can be, for the next couple months. It won't change too much. As we get further and further away, though, it will. And after tonight, we are going to start moving further away from it, significantly more. Because Mars is going to trail behind us in its orbit as we move faster along our orbit. So now's the time to observe it, and if we have a better seeing night, I want to get out here and do some really good imaging on it, because we're still dealing with a turbulent atmosphere. If I do in fact stay here for over the next few hours, the seeing is supposed to improve significantly around 12:30, 1 a.m. So we'll see if I can hold out that long. Might depend on how cold I'm getting or tired. But and I have class tomorrow, early, so I have to watch that. But we'll see what happens. It might be worth it. Oh, it's good to hear, Deshin. I hope, I hope to continue to do these programs, and thanks for subscribing. We appreciate it. We'll keep these streams up for sure. Zaire says, I have a telescope, but I can't see the planets. 300 millimeter. 300 millimeter could... I guess that would be referring to your focal length, maybe? Or, well, I guess it could refer to the actual diameter. Yeah, what would 300 millimeter? Yeah, okay. Yeah. That's pretty good. Good size, if that's the diameter. So yeah, you shouldn't have too much trouble seeing the planets if that's the size of your scope. It is, you do have to just build your skill set up, and if you have a finder scope, definitely use that. That's going to be a nice wide field of view for you to look for these objects. You line it up in the finder scope first, of course, and then you look in the narrower field of view for the main objective telescope in that eyepiece, and then you center it there. So it is you build a knack for it over time, and once you get it down, you won't have any trouble at all. Now, if anyone's wondering what exactly we're seeing here, this, of course, is the full, now that we're at opposition, we're seeing a full Mars. Occasionally when you're on the, past it or before it, you'll see Mars in phase, so it'll be a gibbous. You'll never see it quite at half Mars, but you do get some gibbous phases of Mars, where you're sort of peering around towards the backside of it where it's dark. Right now we're getting a full Mars because we're at opposition, so we're not losing any light. We're seeing just about as much as you can. That's part of the reason why it's so bright. Now, as far as what you're seeing surface-wise, this is the South Pole right here. So this is North Pole, South Pole. And this band, this dark band across the planet, is sort of stretching across the equator, right? The equator of Mars. The dark parts of Mars are indicative of what the surface would look like if you scraped away all that Martian dust and Martian sands. So most of the surface is covered in that rusty colored dust, and it actually is rust. That's why it's that color, iron oxide. When you scrape away that surface, you reveal the rocky interior, the true, I guess, I don't know if it's fair to call it the true nature of Mars, but if you remove that dusty layer, you get into the rocky parts, and that's what you see there. That's similar to what Val Marineris is like, the big canyon that's the width of the United States, that's on the red planet. It's also way deeper than the Grand Canyon, a very large surface feature on the planet. So that's also a dark section of it. So that's what you're seeing here when you're looking at the dark patches. I'm just realizing I hadn't said that yet, but that's the detail we're seeing on it. It's not coming in super crystal clear just due to our seeing conditions up at Kopernik, but it's been coming in and out as far as it's looking not bad right now. One way to tell when it improves is by this section right here. There's a lower contrast part, darker area of Mars down here, similar feature where it's just rocky, a rocky surface that's darker than the surrounding dust layers. When that comes into view, that's when the clarity is improving. You're also looking for a white patch down here. A small little white patch will be one of the poles. This is the South Pole. The North Pole is not visible to us right now. The South Pole is pretty small because it should make some sense if you're having 24/7 light on the South Pole. That's in the Martian summer, and that means the pole will diminish, just like our poles do the same thing. Now, a lot of that material at the poles is dry ice, so frozen carbon dioxide, but some of it is also water ice, and the Phoenix lander, I think in 2008, discovered water ice at the poles, at the polar ice caps. That's all that mission was about. Just find water on Mars. And actually recently some studies came out describing some liquid water, or at least seasonal liquid water features, subsurface features underneath the caps, which is also an incredible discovery. Let's see. I'm not sure if I remember. When is that supposed to be? I can't remember my line of logic, unfortunately. So if you can remind me, I'd be happy to answer your question. It's hard to backtrack in my mind. I think I rambled on for too long. Let's see. Yeah, in this, if your weather is similar to ours, it's that we're in that time of year where it's really easy to fog up our eyepieces. So I guess that is where the benefits of a camera come into play. Less chance of that happening on the optics. But yeah, it's always a challenge. It looks like occasionally we are getting some crisper views. Like right now it's not looking too bad. Again, when these darker regions below the main dark patch come into view, that's a good sign that things might start to improve. I'd also like to welcome anyone that's new to the stream right now. We're happy to have you, and if you're enjoying the stream, remember to like the video. That helps us a lot, and helps us to grow our channel and also understand what you guys are enjoying, because that's what we're here for, is to share the universe with you, but do so where we know you're enjoying the talks, the discussions, presentations as well. So don't forget to leave that feedback for us. And if you haven't subscribed yet, consider subscribing. You can also support us through our donation link in the video description. One thing I will say is once we get above 1,000 subscribers, we should start to be able to activate some features that we currently can't use on YouTube, that you might have seen on other channels. There's a few of them that we're excited to try and utilize just to encourage community engagement and continue to build this community that we have growing. We're excited that so many of you are enjoying the live streams, and we're going to keep going. So that's one benefit, I guess, of crossing that 1,000 mark. Somewhere down the line. Although I will say, YouTube's feature set is pretty robust for just anyone who wants to go and run a channel. It's incredible. I could ramble about that, but I'm not gonna. It's not really relevant. Hi, GH Fear. Yeah, you say, is this live? Yes, it is. I can show you. I have my panel here. I can adjust our view of Mars. This is a view through a 6-inch refractor telescope here in Vestal, New York at Kopernik Observatory. It's a pretty decent view considering our seeing conditions aren't perfect by any means. Surface features, especially the dark patch across the equator, is showing up pretty nice. We're on the lookout for a clear view of the South Polar ice cap, which we saw on Friday every once in a while, but I don't want to say with 100% certainty that I've seen it. My brain is telling me maybe that's it, but I don't know yet. I would like it to get clearer to confirm. But yeah, it's great that you're seeing Mars where you are. So many people seem to have clear skies tonight, so they can watch Mars where they are while they chat with the community here. So that's great to hear. So Robert, what kind of camera are you using? So the camera that's hooked up to our 6-inch f12 refractor here is a ZWO, a ZWO one-shot color. And the model number is escaping me. I can tell you, maybe. Oh, the box is over here. That actually is good because I closed the ladder. I don't really want to open right now. Let's see. I can type it in the chat for you. My name's Jeremy, by the way. So I'm not watching the chat through the Kopernik channel. I'm watching through my account. So if you want to. I'll post this in the chat window, and it'll show up as Jeremy DC if you're curious about the model number for the camera. So camera, it's an ASI 224 MC. 224 MC. And it's a dedicated planetary cam for telescopes. You can also configure it for all sky viewing, so a full 180 degree view of the sky, so you can take in everything that's out there. That's possible as well. They make a monochrome or a black and white version too, which I haven't decided if I want to switch to that tonight. I don't know if I want to mess around with that too much, just because I personally really like seeing the roughly the true color of Mars, that rusty color that we're seeing now. The black and white camera, we could use RGB filters and pull out some additional detail using the red filter especially. But I don't think I want to do that just yet, or if at all this evening, just because I know this is working, and I feel like as soon as I start exploring new things, which is always good, but maybe not to do while we're sharing our view of Mars with you through a scope. Oh, that's funny. A fireman in Vestal, huh? Where are you from, Dishon? If I'm sorry if I mispronounce anyone's names as well. Yeah, it does sort of appear as a reddish yellow. We were observing it pretty early on, and the color hasn't shifted too much. But our tree line prevents us from observing it right when it rises above the horizon. So I'm not sure exactly what the color would have been like then, perhaps a little bit redder. But I like to describe this as like a nice rusty color. Oh, your name is Michelle. Okay. Gotcha. From Franklin, Ohio. Oh, how cool. I love that we get people from all over the states, all over the world, tuning into our stream. I think that's really nice, because one benefit of this, of building this observing community, is that we can share our experiences all over the world. And I think there's a lot of value in that, because the sky isn't really that different, at least depending on what hemisphere you're in, right? It changes for sure across the globe, but it is something we all get to share together, and there's a lot of power behind that. So I think this is great that we get to discuss our observations together. Bill Fletcher. I'm not sure if I know Bill Fletcher. Someone at Kopernik might, though. Yeah, Robert, I'm hoping we do see some improvement. Actually, I've been meaning to check to see what the maximum altitude Mars will reach tonight. How much longer we have until it gets to that point. Where is my app here? Let's see. I'm using an app called Redshift on iOS, in case anyone's curious. It's pretty good. Good one. Full featured. You can even fly to objects, which is pretty cool. It's 41 degrees in altitude right now, where we are. It looks like its maximum altitude is 53 degrees, so we have like 10 degrees to go. And it reaches 53 degrees at 12:41 a.m. So we still have some time before it gets to its maximum height. So its seeing will improve, and as I said, seeing is expected to improve, just the overall seeing across the entire sky, it's expected to improve around then as well. So honestly, I might be waiting this out for for the evening. Like, it's only a couple hours. I'm not. Actually, it's only a couple hours until then. So I'm probably going to wait it out and see what happens, because I want to collect some good image data. I'm not really comfortable with where it's at right now, but as the night goes on, as it improves, I'd love to collect some good stuff. Because I wasn't really happy with what we saw on Friday. It was fine. It was fine, but not super clear. So if it clears up at all tonight, I'll be eager to record some of the data, and I'll process it as well. I may do a processing stream for this one. I don't know. I did a processing stream for the moon on a Friday night 2 weeks ago, something like that. 2 weeks this Friday, I think. And I think it was interesting, but I prefer to get, for a video like that, which is more tutorial based, and for just as like an intro for anyone who just wants to try out planetary stacking and astrophotography processing. I prefer to do a more focused video, because that one was like, I went on for like 2 hours, which is a little bit much for what you really need to get out of a processing video like that. So I prefer to do something condensed that only takes like 15 minutes. So you don't have to watch a whole 2-hour video, because it wasn't as involved as I was making it out to be. But I was tuning into the chat, and we were talking, and also there was one part where I had to wait for something to process, which I should have had it prepared beforehand. But just ideas we're thinking about for the future. It'd be interesting to do some processing videos. One thing's for sure is there's definitely not as much wind as last week, which really affected our ability to image. Mars was like bouncing all over the place. There was nothing we could do. It was just the wind catching the scope. And occasionally Mars would just completely fly out of view. We'd lose it. Not tonight, though. I think I looked at the forecast, and it didn't really indicate that there would be much. Much wind. I think like the max was like 5 miles per hour, so we're okay for tonight. See the chat here. Oh yeah, Emma. Thankfully, the volcano there, Olympus Mons, is so at least I believe, yeah, it should be extinct. So it shouldn't be a problem for anyone visiting. Mars is mostly a geologically dead world. There's not much activity besides the occasional small Mars quake. So you could totally climb Olympus Mons, even though it's incredibly tall. You could climb up it, and it you wouldn't have to worry about it going off. Tasha says, how many satellites do we have in orbit around Mars, and is the data collected from these satellites used to compile images? Yes, indeed, to the second question. These satellites, and I wish I could remember their names. I feel like satellites always get, their names get forgotten, at least for me. I really need to put more effort into remembering them. I know the Hubble, and I know the ISS. Kepler Space Telescope, things like that. But I can't remember the names there's two. There's two. I believe I know there's two satellites orbiting Mars right now, two active ones. And yes, they are studying the surface. They're the ones that collect a lot of image data, send it back to Earth. They're constantly updating us. They're not decommissioned missions. They are going to continue to do that or be replaced at some point, because we need that information if we're ever going to go there. We need to be studying the surface of Mars almost as much as we study the Earth's surface, at least within a practical sense. So those missions have been running for a long while, and they help us determine where we send our robots, our rovers there, our landers, and eventually they'll determine where we send humans. And there's already a lot of potential bases. Now, Mars does change its surface over time. It is somewhat dynamic, not as dynamic as the Earth, because of course there's not much in the way of flowing water, but it does have an active atmosphere, even though it's thin. So the winds of Mars will blow dust around the atmosphere, blow dust into new areas. These dark patches of Mars change over time because of dust storms and big events, atmospheric events occurring. So the satellites are able to keep track of those small changes on the Martian surface, and that software, or I guess webpage, Mars Trek, NASA Mars Trek, is a great Mars map to explore, very detailed and based on image data from those satellites. Oh yeah, we might be seeing Syrtis Major in here. This little bump here might be Syrtis. Or it's this little bump coming around over here. It's a bump. We're looking for like an L-shaped bump for Syrtis Major. This might be it though. Let's adjust the focus again. See if we can get any better. Look at that, we already have to move the dome. The Earth moves quicker than you think. Oh, I meant to comment on this too. Yes, Linda, it was a lot warmer on Friday. It is. I'm glad I came with my somewhat of a winter jacket, not completely, but I'm glad I came with this because, yeah, it's a bit chilly. let's see. GH Fear says, so how did you get into astronomy? And can people rent an observatory for an evening, or how does it work? So I got into astronomy, for your first question there. I got into astronomy around middle school. I really started studying it more. Probably 8th grade was when I started getting heavily interested in it. Actually, before I continue this question, I need to make sure the stream is actually still going, because I'm worried on my end it's showing it stopped. Let me make sure that's not just an issue with our internet. Okay, it looks like it's still running. Yeah. All right. Sorry, I got a little spooked there because I got a loading circle and it wasn't updating. So I think we're back now. I think we're okay. So yeah, 8th grade I got into astronomy, and incidentally, even though I've lived in this area most of my life, actually all my life, I wasn't really aware of Kopernik until middle school, and that was too bad because like Kopernik is great for offering programs to a wide range of students, K through 12, and of course we offer programs like this to everyone. One of our educators and Astro Society members says there in the chat, we're usually open every Friday nights and open to the public. Of course, COVID-19 has affected that, so we've had to curb the public from directly accessing the scopes. But I'll talk more about that in just a second. I should finish the first question first. But I did apply for an internship in 9th grade, and I got it here at Kopernik, and I haven't really left since. I took that through high school, continued to be an intern, and eventually became an educator here and a coordinator. And now you're a live stream astronomer. So I've had a lot of fun up here. I enjoy all aspects of the STEM fields, so science, technology, engineering, and math. But astronomy is my main focus there, or rather, main focus here. And I love sharing it with the community. So the inspiration for it, honestly, even though it's like sci-fi fantasy, Star Wars was probably a big inspiration for it, even though it doesn't really focus on the sci-fi aspects. Just the idea of exploring all these different worlds and flying through space. That's probably what inspired me in my early years. But then as I started delving into the true science of it all, and realizing it's just as exotic as what's portrayed in sci-fi films and stories, if not more so in some cases. That just threw me down a rabbit hole, and I haven't left since. So that's how I got into it. I talked a little bit about too in elementary school. I remember learning a lot about the planets and reading. Very vivid memory of reading in Time for Kids, a little article about the New Horizons probe that explored Pluto in 2015. But I read that in 2005. I think I read it. It's when I was in 5th grade. So that was another big jumping off point there. As far as access to our observatory, like Art says and I said before, the telescopes usually are open to the public every Friday night, but that is not the case at the moment just because of COVID-19 restrictions. We do not have the ability to effectively sanitize our telescopes, and because this particular virus seems to, well, I guess like most viruses, you know, eyes and mouth, nose and mouth, those are the entry points. We just decided to minimize as much contact up at our facilities as possible during these times. But we found our solution right now to share continue to share the telescopes with you through these streams. As soon as we're able, as soon as things get better, we will for sure open up again. This is by no means a permanent solution, although we do think we're going to continue to do these virtual streams in the future, because I think it's a great opportunity to connect with our community locally and beyond. So I don't foresee us stopping these, but we are eager to have people up here again observing. Now, usually we do shut down a bit during the winter anyways, so the winter won't be a time that will be opened up really. It's not usually a time where we're actively open, but we will continue to do observing streams as long as I can bear the negative temperatures. It gets cold up here on the mountain. I mean, it's not a huge mountain, but it's it's the second largest peak in our area. So it's I think 1,700 feet above sea level. 17 or 1,800 feet above sea level. So yeah, that's the that's our plan right now. But we have presentations that we're sharing with you from a variety of about a variety of scientific topics from speakers all across the U.S. We've had Zoe Lerner-Ponterio, who operates the space imaging facility at Cornell University. She's had great talks with us. AstroFest is going to be a big program for that as well. That's run by our Kopernik Astronomical Society, or sort of our astronomy club at Kopernik. So we're sharing programs like that with you in addition to our observing streams like this one. Is the stream still working okay? I see there was some, it sounded like there was some difficulty. Let me know. Oh yeah, War Games. Yes, I don't think I've seen that entire movie. I've seen a significant portion of it though. It was a while ago, but I can totally see that. Yeah, I think creative media like that is integral to inspiring people into STEM fields. Like that's why, I mean, I'm doing the artistic field a disservice, in fact, because I should be saying STEAM, which is science, technology, engineering, art, and math. And I think the creative elements of science are crucial for creative thinking and critical thinking. Yeah, so I think there is a lot of inspiration that comes from that media. I think it's a pretty crucial component. Tasha, in the winter, how do you get snow off the telescope dome? With great difficulty. It can be a little bit of a challenge in the cold temperatures. You have to be careful because you do have to climb up on the very top step of the ladder, or even climb out onto the dome a little bit. And it's not like, you know, it's a regular like 10-foot tall building, if not a little bit more than that. So you have to scrape, and of course the dome is much higher than 10 feet. It's about double, 20, 25 feet, something like that, up. But you're on the roof, just the flat roof, when you're digging the dome out. I mean, in part, the shape of the dome is able to stop the buildup of snow, but that only works to a certain extent. If you're dealing with really icy snow, you'll have to go out there if you want to operate the dome at all. Because if if there's enough ice, it'll freeze the dome on its joint. Joint isn't the right word. I can't remember the name for that, the engineering name for it. But on its axis, on its rotational axis, it'll freeze it, so it won't be able to move. So you need to break that ice to get the dome to function again, and it can be challenging, and in some ways possibly not worth the safety concern about it. So you have to be careful. That's why in the winter time we usually don't operate at 100% capacity. Like, we'll do a program here or there, but oftentimes it's just so snowy and cold. The funny thing though is during the winter time, the skies are nice and clear. The air is very dry, so it is ideal observing conditions, good seeing conditions. It's just very cold. So no, we don't make interns show it off. No, yeah, we don't. No interns are going out onto the domes. Just if there's a willing staff member with someone standing by for safety. It's not something you want to just come up here and do by yourself necessarily. Let's see. There we go. I think our seeing might be improving a little bit for Mars. Again, as it gets higher up in the sky, that's to be expected because the overall atmospheric seeing is only supposed to improve as time goes on. So I'm optimistic. I haven't recorded any data based on the possibility that things are going to improve. I don't want to fill up the storage on my laptop. I think I only have 100 gigabytes to work with, and the files that I record are lossless. So, which is great because all the data is there, but also not so great because it fills up my computer. I just want to adjust the exposure levels just a bit here. It's because this little area right in here is a little bit overexposed. That seemed to clear that up a little bit. Oh yeah, Tasha, that's another big set of programs we do are the scouting programs. It's sort of a fun event for scouts because you have the choice to stay overnight, almost like night at the museum, right? And you get the chance to use our telescopes all throughout the night as long as the skies are clear. So those are really fun programs. Another thing we're missing out on right now, because we can't host big events like that at the moment. But again, as soon as things improve, we will happily resume the scouting activities, our regular Friday nights, and even those that are watching that aren't from our area. We would love to have you visit someday if you're ever in the Vestal, New York area. We're going to keep, especially if you are a subscriber to our channel, you won't see us go anywhere. We're going to keep up with these virtual programs. Yeah, we'd love to have you in person if you are in our area ever, when things open back up again. We get into a nice flow of things on our best nights where we have all 3 of our dome telescopes opened up. We have a bunch of our portable telescopes outside, and people are just, exploring space. Sometimes, we would have hundreds of people up here. I think, particularly during the solar eclipse of 2017, we had well over 1,000, which is not what you'd want to do right now, but it was exciting at the time. So we get quite a few people. I'd like to welcome anyone that's new to the stream here. We're observing Mars right now through our 6-inch refractor telescope. It's a little bit hazy at the moment, but we're expecting things to improve as the night goes on. If you would like to stay up to date on the latest things to observe in the sky and participate in a growing community of like-minded individuals that are interested in astronomy and science, consider subscribing to the channel. We have a very active community and lots of inquisitive people, which I love. So you can hit that subscribe button. Also, it would help us out a lot if you hit that like button too. That helps inform us that you are enjoying or you are engaged in the content that we're providing to you. And also, if you're in a position to do so, there's also a donation link for Streamlabs in the video description. Supporting us through donation, of course, helps us build up our resources to improve our streams and support our building and telescopes. The scope, which you should be able to just about see, the white cylinder behind me, that is the 6-inch refractor we're observing through right now. I just got my, if you have the latest update on iOS, they added sleep tracking and stuff. So I just got the reminder that told me bedtime. It's like, oh, no, I don't think I can quite go to bed yet. Sorry about that, phone. Can't tell me what to do. It's actually kind of a nice feature, I suppose. Tries to keep you on track. It's hard to do when you're into astronomy, though. It's certainly, like someone said earlier, this is certainly a hobby for night owls. I mean, it could be a hobby for early birds too, though. because there's lots to see in the morning skies as well if you wake up early enough. Like Venus or Mercury when they're close to the sun. They don't always rise in the morning. If they're on the opposite side of the sun, then they'd rise in the evening. Or rather, set in the evening with the sun. Oh, Emma with a really interesting question. Emma says, what do you think space smells like? You know, I thought astronauts have given us an idea of it. But it's not, it's more like, you know, when you, like when they, I think it's when they come back inside and, you know, it's on their EVA suits, their astronaut suits for spacewalks. They sort of get a hint of what, like, how space reacts to that material and what it might smell like. Like, of course, if you went out into space, you know, took your helmet off, no oxygen, no anything, one, you would not survive very long, unfortunately. But I'm not sure if you'd smell anything besides, because you sort of need that airflow to make your to success, like properly activate your receptors in your nose. So I don't know if you'd really smell much of anything when you're out there, but they can sort of get us. There's like some weird smell that they describe on their when they return from EVAs, and I can't remember what the description was, but that's the best idea I can give you. I wish I could remember what it was like. I feel like it was like, maybe they said it was metallic or something. I don't know. Oh yeah. Oh, the 5K run. Yep, that was another one of our exciting programs. We called it the Race to the Stars, which I think we've had to postpone this year's program again, of course, to the spring. Hopefully, we can run it in the spring. Yeah, that was a cool event. I think we've run the Race to the Stars twice so far, maybe just once. But it's definitely something we want to continue. And yeah, I think I recall it being a cloudy night, which is too bad. It can be hit or miss in our area for sure. That is Binghamton, the Binghamton area for you. Linda says might have picked up a look at the ice cap. Yes, very possible. Very possible indeed. We're looking for flashes of white in the south pole of Mars, right here. Quick flashes of white. That will indicate the southern polar ice cap. So this is the southern cap, and this is the northern cap. The northern cap is invisible to us, though, because it's winter time in the northern hemisphere of Mars. Now, I will say this region right here is definitely improving. I'm seeing more and more detail as time goes on. And yeah, I feel like there is the occasional quick flash of a highlight there in the South Pole. So I think things are starting to get a little better. We'll see how it improves as time goes on. Let's see. Catching up on my... Or theoretically, if they could take their helmet off, could they smell an object like an egg? Yeah, No, I think you need... If they took their helmet off in that vacuum, you'd need some sort of airflow, some sort of medium for the vapors of the egg to flow through. So I don't think you could. Unless it was like a really volatile substance and somehow enough of the vapors made it to your nose. But the thing about a vacuum is when you have any sort of vapor, it's going to diffuse into the vacuum extremely quickly because it's low pressure, well, basically a zero pressure environment. So it just immediately diffuses, and any dense vapor is just completely lost pretty quickly. So you need some sort of media like air to smell something. So I don't think we could smell the egg. Oh wow, GH Fear all the way from Sweden. Welcome. Well, it's great to have you. I love hearing where people are from. So if anyone hasn't shared, let us know if your skies are clear where you are, if you're seeing Mars right now, or if you've seen Mars this week at all. I just love how this is the true power of the internet, I think, where we can all chat together from all across the world and share in a similar experience. Oh yeah, things are definitely getting better. There's some good detail coming through. Adrian asks, is Mars currently at perihelion or aphelion? You know what? I am not sure right now because the opposition doesn't necessarily sync up with either of those. I mean, it could. There's no reason it couldn't. But the opposition is, of course, just a relation of the Sun, Earth, and Mars, and them lining up effectively in their orbits. So I'm not sure how, whether Mars is close to perihelion or it's closer to aphelion. I couldn't tell you that off the top of my head. Once we figure out a better streaming setup, that's something I could totally look up in one of our other programs, but I don't want to bog down our streaming software right now on this laptop just because it's already occasionally stuttering, so I prefer not to mess with it too much. But if anyone else wanted to do a little research and share with us in the chat whether Mars is perihelion or aphelion, feel free. Oh no, you're right on, GH Fear. The colder weather will certainly improve observing conditions, especially there's a couple of reasons. Yes, you are right that it does, colder temperatures will slow down the molecules, the air molecules. So it's a little bit more stable in that sense. Also, the air is drier in the wintertime and in colder weather, so less humidity is a great thing because that means there's less particulates in the atmosphere. Water vapor is a very high levels of humidity in that sense, water vapor and water content in the atmosphere can vary effectively degrade your image. So lower humidity is great, drier weather is great, and yes, the colder weather does improve on the turbulence as well of the atmosphere. So you are right on there. Ooh, there's a cold rush. Ooh. Sorry for my occasional sniffling here. Yeah, right now it's tonight's an opposition. So the opposition of Mars from the perspective of Earth. So as Mars rises, the sun sets at the same time. Yeah, it looks like I see who commented that. Yeah, Joe is saying has to be near perihelion for close approach. So it's perihelion for Mars past perihelion on August 3rd. And Mars is closest to the Earth at 62 million kilometers. Yeah, okay, on October 6th, which is what we saw. So I think that translated to about 36 million miles on October 6th. But I learned something new about perihelion. Yeah, the detail's definitely improving. Hi, George. Good to have you. I'm glad it sounds like you're getting some good views where you are in PA. Excellent. Yeah, I think 2018 was a little bit closer. But this is certainly a significant close approach. I feel like I read that it was somewhere like 2035 is the next time where it'll be similarly close. So this is a good one. 36 million miles, rounded, was our close approach on October 6th. How far is it tonight? An exact number. Yeah, still around 39 million miles right now. Not too shabby at all. It's a little bit low. Let's get it higher up in the sky. That's not bad. Want to avoid these defects again. Yeah, right in there. I'm just adjusting the focus again just to see if I can improve it at all. Doesn't look like we're going to get much better than that right now. Adrian says, I learned that the clouds of Mars are similar to dry ice or frozen carbon dioxide. Yes, so a lot of the makeup of the Martian atmosphere and the ice on Mars itself in general is carbon dioxide or dry ice. So yeah, its cloud systems are part of that, the dynamics of its atmosphere. So yeah, they're not really water. They're not water vapor clouds like we have here, water-based clouds. They'd be more carbon dioxide based. What time is it now? 11:17. We're getting higher. We're climbing up in the sky. Oh yeah, that's got to be about 45 degrees in altitude now. What's the temperature? Let's see what the temperature reading is. It says 43. Yeah, that feels about right. I think it feels about right. I'd like to welcome anyone that's brand new to the stream at the moment. We're getting some fluctuations in our viewership, which is good to see. So welcome to new viewers. Feel free to ask any questions in the live chat. That is what I'm here to do. We are Kopernik Observatory and Science Center, a nonprofit organization located in Vestal, New York. And we are sharing views of Mars tonight. The opposition of Mars is tonight, and we wanted to bring it to you live from our 6-inch refractor telescope. So yeah, if you are interested in programs like this and talking with a community of like-minded astronomers and sharing your thoughts with them and asking questions and just sharing in the observing experience, feel free to hit that subscribe button or the like button on this video, and that will help us understand how interested you are in more videos like this and improve engagement in the future. And also keep you up to date on the latest. Subscribing keeps you up to date on the latest astronomy news and what to look for in the night sky. So, yeah, hit the subscribe button. And there's also a donation link in the video description if you'd like to support Kopernik. You can support us through the Streamlabs link there. We also have links to our Facebook, Twitter, and Instagram page where we post the latest news, space news, and our astronomy photos as well will be accessible through Facebook and others. Those are great resources for you. If you'd like to visit our website, it is kopernik.org. That should be in the link down below as well. Right now, we are delivering all our programs to you virtually, and we are going to continue to do that for the foreseeable future, if not indefinitely, because this is a great opportunity to expand our community and talk to others from across the world. We all share the sky together, and in fact, the northern hemisphere and the southern hemisphere, we all get to see different parts of the sky, so it's a great opportunity to share those elements with each other. Let's see. Oh yeah, getting some temperature readings from others too. Similarly chilly at different locations. I'm getting a bit of the shivers in the dome here. Like I said, there is a bit of, being in a dome feels a little bit colder sometimes because a significant portion of it is made of metal. The dome especially, and it's that conduction and the convection in the room alone is enough to make the room feel colder compared to the exterior true temperature. Hi, Mountain Vale. Welcome to the stream. Happy to see you again. Getting some pretty decent views of Mars now. Things are clearing up a little bit. Hopefully that continues to improve. It should, to some degree. Supersonic booms. Oh, wait, actually, sorry. David Carter. Hi, David. 728 subscribers. That's great. Glad to hear it. If anyone is new and wants to subscribe to our channel, feel free to hit that subscribe button to stay up to date with our latest programs. Our live streaming programs are the most popular, but we also do other science talks and discussions. We even have a video where we talk to astronaut Chris Cassidy aboard the ISS. You can look at that in our video backlog. There, we communicated to him with him using the ham radio station we have as a part of our observatory, and we set that up with NASA and got to talk with an astronaut. We had our students that were in our summer camp, our virtual summer camp over this year. They got to talk with him over Zoom. It worked really well, using the ham radio station as the hub for that. So feel free to check that one out. That was cool. Supersonic Boom says, "What is your favorite planet?" Ooh, that is a tough one. Well, Can I say Earth? No. Is Earth cheating? I feel like Earth is cheating, right? I think it is. Just because, you say to colonize it and to explore. I see there's more criteria here. Then Mars would be a big one. I also think there's some feasibility that, we could live amongst the clouds in Venus, because the atmosphere, the upper atmosphere of Venus is actually kind of comfortable compared to the just extremely hot surface that's just getting baked under the runaway greenhouse effect of Venus's atmosphere. I think that's possible. But I mean, the moons of Jupiter are a possibility there too. Saturn. I mean, just think about going to Titan and seeing. Well, the problem with going to Titan and seeing Saturn is that the atmosphere is a bit thick on Titan, so you might not be able to see much. But still, the idea is interesting. Where you go to one of the moons of Saturn, and you see Saturn and its rings up in your sky. Wow, that'd be something. I don't know if I can choose. This is a good question, but it's a tough one. I also really like Pluto. I did a bit of what would you call it? I guess it was like a invested report. It wasn't research really because I didn't have access to telescope data. On some other research being done on Pluto even before New Horizons got there. And I did that back in my undergrad, and that was a pretty cool experience because I was able to do that just before New Horizons got there and sort of compare the data between what came before and what was after. And a lot of it was pretty accurate. You can tell a lot just using the telescopes that we have near Earth. But of course, sending the spacecraft there is orders of magnitude better. So Pluto, even though it's not a main planet, one of the main 8, it is a dwarf planet. So that counts too, I guess. Yeah, radiation is a significant problem on Mars. With its, it also has a weakened magnetic field compared to the Earth's, because its interior is not nearly as active. So that presents a problem as well for radiation, harmful radiation for humans. That is a very good point, Adrian. Water in its crust. Yes. There probably is. Oh no, I think it's almost a scientific fact that there's some sort of water in its interior. How much is actually there is another story, but. Daniel, another great question. Why does NASA want a manned mission to Mars, and what is the purpose of a manned mission? Now, this is definitely a scientific debate. We just sort of many might just say, oh yeah, it makes perfect sense to go to Mars, right? Like we went to the moon, let's go to the next thing. Let's just keep going. And while we have that sort of ingrained in our being as humans, to keep exploring, to keep learning, and of course, actually being on Mars. And let's say in a perfect scenario, you have a full-fledged lab there, and you have all the tools you need. Anything that you'd have on Earth, you have accessible to you. That is the best way, for sure, to study Mars. Even if it means you're in your lab and you're sending robots out there, or you occasionally go out on a trek yourself, you're on the planet and you can study it just like you would study the Earth. Unfortunately, that's not really possible at this point in our technology. So, and also the conditions on Mars, like we just discussed, are extremely hazardous. The atmosphere is toxic. There's a lot of radiation to worry about. It's just a complete desert environment, like Adrian said. So it's sort of a wasteland in that sense. It's not a nice place to live. It's not a second Earth by any means. Maybe in its past it was, when it was more habitable, but now it's effectively a dead planet. So there are advantages to being there on the surface and being able to study it in person, just like there were advantages of sending astronauts directly to the moon. But there are extreme challenges faced there, and at a certain point, you have to determine if the risk to human life is worth it, or if you can accomplish enough science, if you can study enough of Mars using robots alone, and from that extent learn about its prior habitability, its current habitability. And that's what we've been doing for the past really few decades, and why humans have yet to go there. Because in part we're studying how to send humans there with our robot missions, but to another extent, they're just way more practical fiscally and when you take into account the cost of human life as well, and the risk factors involved there. So it's a complex issue. Just like the moon landings inspired a generation of scientists and engineers, there's an extreme amount of value of sending the first humans to another planet. But it has to be done effectively and safely. And if that's not possible, then I think our robots will totally suffice. I mean, the fact that we've landed a car-sized rover on Mars at all is just fascinating and fantastic. The effort that went into Curiosity, or even any of the smaller rovers too, it's the peak of human ingenuity. And hey, Ingenuity is the name of the helicopter that's going there with Perseverance, so how about that? Continuing to inspire with those missions. I forgot to mention that earlier. Perseverance does have a helicopter, a little drone with huge propellers, and it's very lightweight because, as I said, the atmosphere is very thin, so you need a larger span, propeller span, and very lightweight craft to fly around in the atmosphere. So that'll be really cool. That's the Ingenuity spacecraft, or flycraft. Not exactly sure what they call it, besides helicopter or drone. Not sure what other name they have for it. So, yeah, it's a great question, Daniel. It's a very complex one, but I hope I was able to answer just at least the motivation behind it, and the cost-benefit of it, of sending humans there. Oh, you have a follow-up. Daniel also says, what would be a purpose also for colonizing Mars and other planets? So that's where you sort of you potentially get into some sci-fi elements, and in the human nature elements too, of wanting to explore, continuing to push our boundaries, and on a very evolutionary scale, how would you say this, I guess? The goal of a life form is to survive, right? As a species. And the best way to ensure the survival of the human race is to go beyond the Earth. Because the more planets you colonize and you occupy, I guess, for lack of a better word, the more likely your species will survive through, millions of years, if not more. So there are benefits there, and that's probably like the long-term benefit, and it's also just a deeply ingrained benefit of Earth-based biology, and I'd assume all biology through the universe if there's more out there. So just to survive, and to keep going, and let's see, am I moving into the dome? Wow, I'm moving into the dome again. Look at that. There we go. Brighten things up a little bit. Get some more detail out of the scope. because we were looking through half of the dome, half dome, half sky. So that's why it was getting a little bit darker. But yeah, there are major positives to going beyond the Earth, and like if you've ever seen Doctor Who, that's a particularly, or even Star Trek, but Doctor Who's coming to mind because I was on a rewatch recently. So like there's, I think in like series 4 of like new Doctor Who, which is like the post 2005 stuff with David Tennant and whatnot. There's like a whole arc, and it's a consistent arc too throughout the series, where like humans are just everywhere, and it's just a matter of fact that like they're the species that survives. And I think it's a little, to that extent, like, why are we the species that survives when there's so many others out there? You know, I think it's a little bit like high on human life in that sense. But of course, like humans are the focus of that show anyways, to most in most episodes. So like I think that's one aspect of it, but that's just one sci-fi idea where like you want to keep going out there, and like I think the show goes as far as like, you know, 15 billion years or 50 billion years in the future or something, when the universe is dying and like humans are still alive. It's like, I don't know about that, but wouldn't it be amazing if we could survive the whole of the universe? Eventually it won't be possible, but hey, worth a try, right? Okay, that's a good scientific and philosophical question, though. Exactly. Yeah. Yep. Some good thoughts here. Like on one front, like Adrian says, it's you know, a matter of getting there, exploring Mars, understanding Mars, because and another valuable idea about all this is when you explore, when you push these advances to get to these worlds, like the moon, you advance technology to a supreme degree. And we benefited a lot from both the moon landings and the International Space Station. And as a species, we benefited. And a lot of the technologies we have today wouldn't exist without those missions. So there's a lot of benefits there technologically. There's a lot of value in understanding the history of Mars to understand the future of Earth. So yeah, the interest in going to Mars or other worlds is really endless. And it's also just that question, are we alone, you know? Has life formed on another world independently? Which I think statistically, yes. But we have to prove it, right? We have to prove it without a shadow of a doubt. Yes, Venus does have acid rain. The atmosphere is very toxic. Very toxic. David, yes, we'll have to leave Earth eventually, one way or another. Indeed. Linda says Earth is my fave. Yes, I do have to, like, just as a widespread, like, what's your favorite planet? I gotta say the Earth. We wouldn't be around here without the Earth, right? That's why we gotta protect the Earth too. Of all the planets you visited, Earth is your favorite. I like that, Montebello. Blue Moon says, do you think there is any life form on Mars? Wow, we have so many good questions here. I'm trying to catch up. I'm sorry. I'm really behind. I've talked for too long on some of these. But do you think there's any life form on Mars? Right, like currently, is there any life form on Mars? I don't want to say yes or no. One, I'm not an astrobiologist. My background is in physics, strictly physics, and astronomy. So I can't really put my, like, as far as it's like, what's my thought on it? I think there could be. Like, thinking about the extremophiles that exist on planet Earth, I certainly think that maybe one was able to fill a niche and once Mars started dying, effectively. Its inner interior started to cool down and the surface became desert. I think something could have survived, sure, and filled the niche that could be supported by life. Found a way to live, because we know there's some sort of liquid water, subsurface liquid water on Mars. There was definitely liquid water on the surface in its past. So I have no reason to believe there couldn't be some form of life on there. But again, it's like microorganism life. I doubt it's anything intelligent. Again, if you want to do the Doctor Who references, I'm not sure if anyone's fans of Doctor Who in here, but they have like the Martians in Doctor Who are like the Ice Warriors or something, and they existed on ancient Mars, and eventually there was some catastrophic event, and they hibernated underneath the surface. I don't think that's the case. Is it impossible? Probably, but I think there's a 0.0000001% chance that's possible. Good questions, everyone. Oh yeah, absolutely, Daniel. If you we have to take into account that what we're doing to our planet is unsustainable right now. And one, I will say right now, it's easier to survive on Earth, regardless of what happens with climate change. It'll be easier to survive on Earth than it will be to survive on Mars, unless we start terraforming Mars. But when you think about it, it's going to be more difficult to terraform Mars than it is to fix the Earth. So I think we should colonize Mars in addition to being on the Earth, but it's by no means our substitute, unfortunately. We can't just all jump over there. As nice as that would be. Holiday on Mars. How does that sound? Things are getting better, I think, on the red planet here as far as detail goes. Let's do a little bit more focusing here. Things are clearing up for sure. Getting much more consistent detail that doesn't fade in and out as quickly. And I think the South Pole is starting to stick around. You see this white spot right here? That's the southern polar ice cap of Mars. And we're consistently seeing it at this point. In addition to the darker details below the main equatorial band across the planet there. Humans evolved on Earth, so it will always be number one. Yes, I agree. We have evolved to survive here. So it's best to make survivability here work. Yeah, terraforming, Daniel, is certainly a long-term option for Mars. If we could somehow revive the planet and bring life back to it. I mean, like one idea that with Mars is that, I mean, you to some capacity you want to pump its atmosphere so it's thick again, and you can basically pump it with carbon dioxide or other greenhouse gases, and bring it back to life and warm it up with that greenhouse gas. Oh, Montanville says, for me, Doctor Who is Tom Baker. I watched about half of Tom Baker so far. I'm ever since it got, I was halfway through the Tom Baker stuff until it got removed from Hulu, and now I don't know where to watch Classic Who. So I didn't get to see all the Doctors yet, which is too bad. I really did like Tom Baker. Dana says, how would we terraform Mars or other planets? So Mars does still have a lot of carbon dioxide in the form of dry ice, especially at the caps, and just stored within the crust of the planet too. So it would be a matter of getting that carbon dioxide into the atmosphere. Furthermore, if there is other ways to burn, like a fuel source, anything that you can burn on Mars, like methane, which I don't think is terribly common from what I remember reading, but something like that where you can burn it and pull more carbon dioxide into the atmosphere. Anything like that. You want to build up, basically do what we're doing here on Earth, but on Mars. In fact, that'd be a great thing, wouldn't it? If we could just transport all the CO2 here to Mars. And methane. As far as other planets go, I don't know if there's really that much hope to terraform Venus. If anyone knows of any theories on how Venus could be terraformed, feel free to put it in the chat. But I know you could potentially build, cities in the clouds like Bespin in Star Wars. Lots of sci-fi references tonight, or sci-fi fantasy in that case. But Venus, you could potentially live in the clouds because it's nice and warm there. Not temperate, not like the scorching surface. With Venus, you'd have to reverse that massive greenhouse effect they have going. I just don't know how you do that without massive chemical reactions on like a huge scale. So, for an intelligent humans or other species in the future, that's a problem for them to solve. Things like Enceladus and Titan, Europa, all those icy worlds that possibly have a subsurface ocean. Maybe you could live in the ocean. But it really becomes a problem of like, how do you transport all this stuff there? Enough stuff to colonize it. That's where the issues really come down to. You'd have to manufacture on a huge scale. Mars would probably be our best option for terraforming. Oh yeah, commercial travel into space. That's a good, yeah, it would be a good reason to start saving money. I mean, it is starting to become a possibility for, the richest among us, where you can board Virgin Galactic, that sort of space plane, that it's part rocket, part plane. The rocket detaches and it flies into low atmosphere. You get like 5 minutes of space and then come back down. Which is something, I shouldn't really joke too much, because I mean that's enough to change people's perspective on life, really. Like, you hear what the astronauts have to say about their perspective up on the ISS, and it's just incredible. So even 5 minutes I'd take. But I think there's even some rumblings of like Tom Cruise going to the ISS. I don't know how credible that all is, if that's actually going to play out that way. But yeah, commercial travel into space would be something, especially if it became affordable like air travel. Oh, let me get this pronunciation right. It's a mountain. Oh, I'm not familiar with the mountain. Where's the mountain? I haven't heard of it. It's a mountain in... Oh, I should have read the next line. Malawi. Oh, jeez. Matambale. Matambale. Okay, gotcha. Lonaz said in 1975 says, "What telescope are you using?" So we are using, behind me here, I'll turn the lights on for a second. You can see this is our 6-inch refractor telescope. It's an f12 refractor, so it's a really long focal length. And it's a superplanetary refractor. If I remember, someone mentioned, this telescope has been here way before me, but it's, I think someone said it's one of 25 in the world. It's a specialized refractor for planetary views, but it's good with deep sky stuff too. And it's on an equatorial mount right here. The equatorial mount has a motor in it as well, so it is able to track the sky. It can't find objects for you, you got to do that, but it can track them once you find them. This is a telescope located at Kopernik Observatory, that's where I am right now. And we are in Vestal, New York. So we have this trained on Mars using our camera system. Daniel, it says, what's the difference between a planet and a dwarf planet? Another good question. So there's a couple of different factors at play with dwarf planets. Of course, the most famous dwarf planet is Pluto, and there was great debate about whether Pluto was a dwarf planet or not. It is currently classified as a dwarf planet, not one of the main 8. On one definition is if a planet is something that is the singular body that's occupying its orbit. There's not any major bodies within it or close to it. So Pluto sort of already gets a strike there, because Pluto does intersect with Neptune, and Neptune's the superior body in that orbit. So that intersection is already one sort of declassification for Pluto. More than that, though, Pluto does not have as circular an orbit. Our orbits aren't perfectly circular, they are elliptical, but Pluto has a little bit of a greater elliptical orbit compared to Neptune. That's actually why or any of the inner planets, that's actually why it's able to intersect with Neptune's orbit. So that's a challenge there too. What else? Oh, and it's also, there is a large body that's part of Pluto's system, and that is Charon. Charon is the moon of Pluto, and it's really almost large enough to be considered a binary planet system. It's about half the size of Pluto. It's a significantly large body, a little bit under half. And is it a little? No, it might be like a third. I think it's a third. I don't think it's quite as big as a half. But either way, like it's a significantly sized body, and almost a little bit too big to be considered a moon. So there's been thoughts about calling it a binary planetary system. Let's get rid of that little speck there on Mars. There we go. What else? I'm missing something about Pluto that I forgot now. I mean, size comes into play there. What else did I say? The orbit comes into play, intersecting orbit with Neptune. Oh, Pluto's orbit also doesn't line up in the plane of the solar system, which is interesting. It's not perfectly aligned with the plane. It's at an angle. So most of the planets fall along a plane that formed with the accretion disk of our solar system. The accretion disk is what formed the planets effectively. The proto-solar system had this accretion disk, and the material from that accretion disk formed the planets. And because it was a disk, all the planets fall along the plane. But Pluto comes in at an angle to that plane, its orbit. So that's another thing at play there. It's not part of that main accretion disk. It formed in some other way compared to the main planets. So Pluto is a part of the Kuiper Belt objects. And there are many dwarf planets in that Kuiper Belt. They've also, like, a lot of them are pretty sizable too. By volume, the dwarf planet Eris is larger than Pluto. It was discovered after Pluto, and that became, one of the topics of discussion when trying to determine Pluto a planet. So they decided ultimately to classify these objects as dwarf planets. There actually is a dwarf planet in the inner solar system, and that is Ceres. Ceres is in the asteroid belt. So these aren't just restricted to the Kuiper Belt. That dwarf planet is in the asteroid belt in between Jupiter and Mars. Okay. Oops, lost it. There we go. Yeah, things have improved here on our detail, in terms of detail that we're seeing on Mars. Hopefully it continues. Build a long tube from Earth to Mars and let the gases flow to Mars. Yeah, that's one solution, right? Linda, that does present that's a good question too. Terraforming, even if some form of life is already there. That's a good ethical question. And I mean, also, I would argue, not just ethical, it's a scientific question too. Like, do we really want to interfere with the evolution of life on another world? But then that begs the question, did something interfere with us? No. There's no evidence for that, except for regular biological and evolutionary forces. Yeah, GH Fear, Tom Cruise is certainly a thrill seeker, and he does all his own stunts. So if he's making a space movie, you got to go to the ISS and be in space, right? I think it's something that was mentioned with SpaceX, and I don't know how. Well, actually, no. I feel like it was actually more than SpaceX. I feel like it was directly mentioned by NASA and talked about. We'll see what happens with it. It'd be interesting. But if he's an actor that's going to go, I get that it would be him. Yes, Ceres in the asteroid belt. It's a huge asteroid, dwarf planet. So, Boba, where is Mars in the sky? So right now, Mars is pointed, I would say it's south, let's see, where are we here? Here's my east. Yeah, it's almost due southeast right now, in the southeastern sky. I mean, it depends on where you are. That'll depend on where it is in the sky for you right now. We are located in Vestal, New York, but that might be different. If you go to stellarium.org, let me put it in the chat. My name is Jeremy, and it'll show up as Jeremy DC. I'm not using the Kopernik channel right now, unfortunately, to put stuff in the chat. It's just easier for me to do it this way. Stellarium.org. That is some free planetarium software that you can use for Windows, Mac, and even just over the web. And you can use your location to figure out exactly where these objects are in the sky. It's pretty intuitive to use, especially the web-based version. So you can give it a try and see if you can find where Mars is for your location. It's pretty high in the sky where we are, but again, that does depend on what time it is in your area. Oh yeah, I'm not sure if Mars has much of whatever's there. I don't think would be very edible. I think it's just microorganisms. If any life is still there, it's just basic life. Trying to find a sweet spot for the focus. That's not bad. Dome is going to move. That was just our dome shifting. Okay. Yeah, the Lorna, the polar ice cap. Yeah, it has shrunk quite a bit. I mean, even like over the summer, it was pretty large. I remember it came up pretty clearly even though Mars was a little further away, it looked pretty good. But now at this point, it is pretty small. Little tiny cap. The southern ice cap is right down here for anyone looking. It pops into view every so often. It's definitely not as easy to spot as it once was. Does that system give you a warning that the dome is about to shift? Oh no, yeah. Actually, I have to manually switch or shift the dome when I notice that the telescope is moving into the dome away from the object. So it's not something that's terribly automated. We would love for it to be automated, especially with the 20-inch reflector. That'd be awesome. But it's quite a large expense, especially on these older domes, to get that to work. Something for our future, though, to think about. $12:06. Wow, thanks for sticking with us, everyone. This has been great. I'm going to keep going here, just because everyone seems to be enjoying the stream. So if anyone has any questions, feel free to ask. I want to offer those that are new to the channel, feel free to hit that subscribe button if you want to stay up to date on latest astronomy news. And watch for future observing sessions like this one. We definitely want to continue to provide these to our viewers. So subscribing is the best way to keep up to date. Also, if you haven't already, hit that like button. That does support us. It's one of the best ways to support us and our channel, in addition to subscribing. And if you'd like to support us through donation, there is a donation link in the video description. We are up to 731 subscribers. Thank you guys so much. That's awesome. I'm glad we have this growing community here where we can, we got some black specks on Mars. Earth specks that we don't want. Oh, thank you for the reminder there, Daniel. Yes, we have the moons of Mars, Phobos and Deimos. I haven't mentioned that. Yeah, those are two captured asteroids around Mars. Two small moons. Not easy to see through a telescope, although I was browsing the astrophotography subreddit on Reddit the other day, and someone had imaged, I can't remember which one it was, Phobos or Deimos, one of the two, of course, because there's only two. But they had imaged one of the moons just as a very faint spot. Not easy to do. I'm not sure. I can't remember what telescope they were using, sadly. I'm almost comfortable enough with what I'm seeing. Almost. As far as getting some image data for later processing, I definitely want to collect some good data tonight. Whatever I can get, because I don't want to miss out on this opposition. Yeah, it's steadier than the other night. Yep. Yeah, it's definitely not windy. Like the wind is very dull if there's any at all. There's Friday night was really bad as far as wind went. not ideal at all because it was whipping our view of Mars all over the place. So thankfully, don't have much to deal with on that front. But the seeing still isn't great. I think it's better, potentially better than Friday. But I mean, it says at 1 a.m. that it's supposed to improve even more. 1 a.m. our time, Eastern time. But we'll have to see. Let's see what I'm going to check. Yeah, it's still saying 1 a.m. is the seeing is supposed to improve a little, which I might wait for. I have class tomorrow at 8:30, but you know, the opposition comes every 26 months, so. Yeah, there's some good detail coming in right in here. And the southern polar ice cap is showing up a little nicer. The band is showing up nice and clear. Yeah, I think we're doing okay. I'm pretty happy with what we're seeing right now. It is physics. Oh, well, I guess the morning class isn't quite entirely physics related, but we'll count it. Most of my classes are physics related. The nice part, though, with classes right now is everything's virtual, so it's not like I have to travel anywhere. I can just wake up 8:25 and go to class at my desk. The commute is really short. Yep. Indeed it is. Oh yeah, so Daniel, I'm a college student, a graduate student really, in a sustainable energies program. So Kopernik is my job. Well, this is volunteer work right now, but I do other Kopernik work. That's my job, and then I am also a student right now. With Ornaz is watching right now with a 10-inch DAW. Very nice. Oh yeah, we have a great community of volunteers. Although, you know, we haven't had a lot to do over the the virtualization of things and the closing down of our facilities. Just like thinking, like we have interns and we have adult volunteers and everyone supports us with our class programs and all this, but there just hasn't been enough going on. So I've been helping where I can with the observing stuff here and there. And it's going pretty well, I would say. And it's also like, it's a hobby. You know, I'm observing anyways. I want to see Mars. And I want to talk to people who also want to see Mars. Welcome any new viewers who are joining the stream. We are observing Mars through our 6-inch refractor telescope here at Kopernik Observatory and Science Center, located in Vestal, New York. We have some pretty decent views tonight, despite some poor seeing conditions. We're getting some good detail on the surface. I'm here to answer any questions that you might have about the red planet, about space in general, about science. If you'd like to see more content from us, feel free to hit that subscribe button. That will update you with the latest information about future programs, presentations, and observatory live streams. You can also support us by hitting that like button. You can see I'm zipping my coat up more and more as time goes on. As the temperature continues to drop. I wonder what it is right now. If it dropped any, or if it's going up. Is it going up? Oh, it did go up a little bit. 45 degrees now. Doesn't feel like it went up, but that's all right. All right, I think I'm going to start adjusting the focus again and maybe collecting some image data. Get the dome moved over a little bit. That'll give me some good time there. Should be far enough away. Zoom out just a touch there. I gotta stop full screen for a moment. Wait, you know what? Let's see if I can bring it up towards... I didn't realize we were so far down. Let's try that. Let's zoom in again. I'm just prepping the camera for imaging. I like that, I think. Okay, let's take some video. Someone says, how can I see Mars? So there is a program. If you go back up in the chat, there's a link to it called solarium.org. And that's a great way to try and find Mars. Right now we are located here in Vestal, New York. And Mars is in the southeastern, well, actually almost due south now. Yep, almost due south. Part of the sky, pretty high up. That might be different depending on where you are. And that's where that Stellarium program comes in. There's similar applications on smartphones, like Starwalk and SkyGuide. And you can use those to pinpoint exactly where these objects are in the sky. Oh, I should stop this because there's a little bit of a defect in the lens again. Try that. Run it again. Let's see what else we have here. Yeah, the southern hemisphere is very, very rich with detail at the moment. Gosh, I just can't find a clear patch of... I don't want any of these defects, and I don't really want to worry about them during processing. So let me see if I can find a really good clear patch in our optics. It's hard to find. There's quite a few of them. It might be impossible to avoid. That looks okay. Can the human eye see it in person, or do I need a telescope? So you can see Mars as a point of light, a bright point of light in the sky with just your eye. You don't need a telescope for that. It is very bright. So the brightest object you see right now for us, again, it's in the due south. If you look up and you see a really bright object, that is Mars. It should have a little bit of a reddish color to it, or like an orangey, goldish color. Live in Pennsylvania, and I'm trying to find it, but I don't know where. Okay, yeah, so PA, same time zone, so you shouldn't have too much trouble. If you look due south, maybe if you have a compass on your phone, you can use that. Look due south and look up, and you should come across a nice bright point of light. Now, to see detail on Mars, you do need a telescope. So yeah, if you do need really some like significantly powerful binoculars or a scope to make out some detail on it. Yeah, GH Fear. So he says, do you guys ever use AI or other software to pull out some extra detailed images of the planets from a data set of frames? I have seen people do that with landscapes, but it wouldn't work well with planets. It works incredibly well with planets, and that's actually what I'm preparing for right now. Let me stop this because I've already reached a high capacity there. Yes, this works really well with planets. It's called image stacking, and like you're saying there, from each frame has a different set of details for Mars. And when you stack these frames, you can use the best details in each of those frames and stack those details on top of each other to make a more complete image. Because you can see at any point there's higher clarity in this region compared to this region, or this region compared to this region. So you want to take these moments of high detail here and high detail here and stack them on top of each other. So everything's clear rather than some parts being clear and some parts being fuzzy. And that's all because of the atmosphere, why it's so hazy in that way in certain areas. And image stacking allows us to fix that and get a really detailed image out of it in the end. So yeah, we use a couple different pieces of software, at least I do, for processing. If you want to go back to one of our videos where we did that, there was about 2 weeks ago, we did a video on how to image stack the moon. So you can go back and check that out. There's some information about the software we use in there. But I can give you the names. I used AutoStackert, which is for the actual stacking utility. There's also one called RegiStacks, which I didn't use for stacking. I used it once I got the stack picture from AutoStackert. I uploaded it into RegiStacks and was able to adjust noise and sharpening levels on that. So yeah, well, that's what I'm doing right now, is collecting data for a stacked image of Mars. So I'm recording a video, a lossless data video, for stacking purposes. Great question. Oh yeah, it's certainly bright enough that it should make it through some cloud layers for sure. Consistent Samurai, I like that name. So Lorna has 1975. What magnification are you observing at? That's a hard question, only because we're using a camera sensor, and while it's a little bit more trivial to calculate using an eyepiece, I'm not really sure how to do it with our sensor here. I might have to look into the specs of the sensor and the equivalent, like if you were to equate the sensor to an eyepiece, how would it look? So it's hard for me to estimate without direct, and I could also like give you an estimate if I was looking at like stellarium or something in field of view of Mars, but fortunately I can't load that up without negatively affecting the stream right now, so I'll have to hold out on that. But yeah, it's hard for me to give you an idea of the magnification at the moment. Ooh, that's another big file. Okay, well that's a good couple of files I have there for right now. I don't want to fill up my storage. So I'll go back to the full screen view for you. Zoom in a little bit. Oh, I wouldn't worry, consistent Samurai, too much. Because, as far as Mars goes, at least, while this is, the next close approach, like really close approach, is 2035, we'll still have some other opportunities. Every 26 months, we are at opposition with Mars. So while we won't be on a super close approach like we are right now, and like we were back in July of 2018, which is even closer, there'll be other opportunities for observing again. Not as good as this, but and even still, while we are gonna, after today, we're gonna be moving away from Mars a little quicker. Throughout October, you'll have opportunities to observe Mars, like as it is, just about as it is right now. So yeah, you'll still have some opportunities to see it up close, even if your skies aren't behaving right now. Let's see, GH Fear, Ready Stacks. Yes, I'm checking out. Yeah, so yeah, definitely check out Ready Stacks and Auto Stackert. Those are some good programs to get you started. If you want to do deep sky stuff, there's some better software, like Deep Sky Stacker is better for deep sky stuff, of course. I think there's also one called Sequitur, which is good for, I think that usually that's used for the wide field stuff, like you were mentioning landscapes. I think that's a good one for that. From what I understand, you can also do manual image stacking through Photoshop, although I don't recommend that for a lot of astrophotography purposes because the software that is out there, one, it's free. A lot of these are open source softwares. And two, was two. I forgot what two was. It's very efficient compared to running stacking through Photoshop. When as 1975, you using Prime? I'm not sure what. Prime focus. Yeah. Yes, yeah, we are using Prime focus on the camera. We don't have it linked up to an eyepiece. Sorry, I had to backtrack my thoughts there. Yeah, you're south, Colorado, you're southeast, and we're basically due south now. So yeah, there's certainly a big difference depending on where you're located. Although it's getting so high up, it's almost like you're looking at it as zenith. Not really. Zenith is of course 90 degrees, and I think the maximum for tonight is at 12:41 a.m. It'll be, we're almost there too. At 12:41, it should reach to 53 degrees in altitude. Consistent Samurai asks, do you believe in aliens too? That is a good question. I will say statistically, through the power of maths, yes. I think it's, some form of life has to be out there mathematically. We have to prove it though. Beyond the mathematical interpretation, I want to see it proved by exploring space. And it might be closer than we think. It might be in the clouds of Venus, like they've recently discovered compounds that, as far as we know, are only produced in the presence of life. Or Mars, in the subsurface waters of Mars. And it says it's getting foggy in Owego now. Mars is the only thing I can see. Well, that might be beneficial to Kopernik only because when there's a fog layer coming through the valley, that's usually beneficial to us in terms of visibility up here. Which I don't mean to take the your misfortune for granted. Because obviously I want everyone to continue to observe Mars, but it's just good to know for imaging. So I appreciate the info there. Yes, Matambale, see the Drake equation. That is exactly right. If you do a little research on the Drake equation, you'll learn, the chances of life are extremely high. That's just one mathematical model. There are others out there. But it'd be amazing if it was something we could prove within our lifetime. Most likely, the only way we could is if it survived, if there's life surviving in the solar system somewhere. I don't necessarily expect us to discover life outside of our solar system. There's been a beetle very slowly making his way across the dome. And I would say he's moved in the past, well, since I started streaming, I would say he's moved maybe 6, 7 inches. I think he's a little cold. I do not blame him. Proportionally, I've probably moved the same distance. Yes, moving faster than the beetle. We might have some new viewers in the stream here, so welcome. Happy to have you. If you have any questions about Mars or space, feel free to ask. I'm your resident live stream astronomer here at Kopernik Observatory, and I'm happy to discuss some things that come to mind. We have a great community in the chat here, discussing all manner of scientific topics, mostly about space and about Mars. But feel free to chime in. We're happy to have you. If you want to see more videos like this one, hit that subscribe button. We'd love to see you again and become part of our community. You can also support us by hitting that like button in the video here. That helps us with engagement. GH Fear says, I wonder if humans will ever travel outside our solar system. Given enough time, perhaps, in a few billion years. I wonder what society will look like then. Yeah. Yeah, given... It's really just, all about resource management and, yeah, it's a difficult question to determine if the technology is even feasible based on the resources we have in our solar system or on Earth alone, if we can make it outside the solar system, make it outside and into interstellar space. It's really a complex topic, but one worth discussing. And if it means, especially when it means the survivability of the species in the long term, meaning like on the billion-year or million-year time scale. And one thing to think about too is the forces of evolution haven't stopped either. So who even knows what human life or life in general on Earth will be like? Life in the solar system will be like. A billion-year timescale is incredibly long. Then will you share the video/data you get tonight on the website? So this video will be posted as soon as the stream is over. It'll be posted on the YouTube channel, so you can always access it there. I will be hopefully using this data to compile an image, a final processed image of Mars with all the stacked frames, so we get as much detail as we can. And I might do a video on that. That'll be posted on the channel as well. The data is another issue. It's not easy to share it because the file sizes are so massive. It's something worth considering in the future if we were like able to set up a cloud server, be that through Google Drive or wherever, for people to access. And I think that's definitely worth considering in the future. But as of right now, it just would be a little bit of a challenge to share it. We will post the final processed image on Facebook. And we could at least like put together a Google Drive for posting the full resolution image, because I know Facebook will downgrade the quality of the image. So if you wanted the full resolution, we could potentially post it on our Google Drive, and we can share links for that and everything once we get it organized. Yeah, the final image we'll have for you to see. Yeah, every so often Mars gets nice and crisp, but it fades a little bit again. Still some atmospheric turbulence. Just trying to find the sweet spot again. That's okay. Whew. I may be reaching my temperature threshold here as far as how cold it is in the dome. I don't know if I'll completely shut down the stream quite yet, though. I feel like I'm going to leave it. I might leave it up for a little while. Because I can always just head inside and leave the stream running. I'll probably have to zoom out the view of Mars a bit just because I don't want it to move off screen. But just so people can still see it. But I might have to go inside and warm up. Thanks, guys. Let's see. Thanks for joining us, GHPeer. We were happy to have you. Hello again, John. Good night, you guys. I'm not shutting off the stream quite yet. I'm just saying good night to those that are leaving. I might head inside to warm up a little bit, but I think I'll leave Mars going and then come back. Just because I am expecting the sky conditions to improve even a little more than they are now. Oh wow, excellent. Sounds like pretty successful observations there with Mars and Jupiter, John. Very good. Okay, so I'm going to leave the stream going for now. Let me zoom out the field of view a little because I don't want it to move out of view there. So this is where we'll leave it. A little bit of white space, but it's okay. I think it's moving to the lower right, so we'll put it there. I will be back. Maybe I'll warm up 5-10 minutes, and then I will return for any questions anyone has, and some final imaging for the night. Let's put this here, shrink it down a bit. There we go. Okay. Yeah, so anyone that tunes in knows what's going on. Okay. I'm going to go warm up a little. I'll see you guys. Anyone, well, you don't have to stick around, but if you're here when I come back, awesome. All right. How did it already get down like that? Let's keep in the tension on the... Bring it back up here. There we go. I'll watch the stream inside, so if it does move off, of course I'll be able to come back out. But I'm pretty sure that should be okay where it is. I'll be back. How's it going? Not looking too bad. Let's see. I'm back, everyone. Oh, just in time to move the dome. Okay, warmed up a bit. Already cold. Again. It never lasts very long when you go inside to warm up. There's my mouse here. Let's see. Not too bad. Might try and capture some more image data here. I kind of want to switch to the lower power again because the seeing still isn't amazing. So what I might end up doing, let's see, I'll zoom out here. Take some video there. When you switch to a lower power, you are it'll almost look like you end up with more detail because we're kind of pushing the resolution at this point. We're not going to get much more out of the sky this way, but I mean that doesn't look too bad. Oh, but we're having a little black spot show up again. There we go. It really doesn't look too bad when things clear up a little in its view. You know, you start to make out a little bit more detail, and then it'll disappear for a little bit, and it'll come back. So stacking will take care of that, certainly. I don't expect to stay too much longer, just because 1 a.m. almost was already pushing it for me. I'm glad I stuck around for the improved seeing, which it did seem to improve as the night went on, so we could finally get some good data. But I will have to wrap things up in the next 10-15 minutes or so. I think we'll spend a little bit of time getting some more data. I'll reduce the magnification just to see what I can get out of it with a lower or with a wider field of view, and then we'll wrap it up. So if anyone has any questions, happy to answer them. If you're just joining in on the stream, welcome. I'm from Kopernik Observatory and Science Center here in Vestal, New York, and we are observing Mars, the opposition of Mars to be specific. And it's put on a pretty good show for us tonight. I'm pretty pleased with what we've been able to see. We've had some great commentary. Between a bunch of different people in the chat. Some great questions from them. It's a really exciting night, I think. Let's try a different focus here. A little bit of an adjustment there. Okay. That does this any better. Yes, I'm looking forward to see how it all turns out. There's all these little, that's one reason why, I think it is in the Barlow, because when I don't use the Barlow, I don't notice nearly as many defects. But then again, it's also magnifying at a different focusing on a different level. So it could be the focuser too. I don't know. As far as those little specks on our field of view, but they're quite annoying to avoid. So that's another reason why I want to go to a wider field. Oh, Baloo. It's good to enjoy a Mars bar snack. Yes. Oh, and I missed this one too. This is a profession for night owls. Yes, indeed. Which I most certainly qualify for. That title. Oh, I don't know. Ooh, there's a breeze. Ooh, that's a very cold breeze. not super windy, but oh. Not a powerful wind, but enough of a breeze to. There, and do another focus level here. These little specks. I'll be able to see nebulas with a 70-800 telescope with a zoom lens. Is that 70 millimeters? I mean, one really good, regardless of what size telescope you have, if it's a small one, if it's a large one, doesn't matter really. One really good nebula to look at is the Orion Nebula. Orion is a great go-to for looking for deep sky objects. It's nice and bright. You should be able to pick up some decent cloud layers from it, so you can see the gases around the stars. It's pretty good. And if this is with visual observing, if you have a camera hooked up to it, even a 70mm refractor, you can make some good progress there too. As far as filters, it sort of depends on what nebula you're aiming for. RGB filters are always handy for bringing out detail in different objects. Even an H-alpha filter might be useful, but I'm not sure how useful at that size. I'm not quite sure. Thanks for joining us, Blue Moon. Happy to have you tune in, and maybe we'll see you again sometime. All right, I think I'm going to switch on over to the wider field of view, like we had it at the start of the stream. So bear with me for a second. I'm going to put our banner back up for switching magnifications. And we'll wrap up the show at that magnification level. Okay. Okay. The eyepiece is nice and eye level now. That's convenient. Yeah, see, that's a little bit crisper, and we don't have to worry as much about those little defects in the lens, little dust particles and whatnot. So I like that quite a bit. That's pretty good. All right, let's do a long video with this one. Oh, I missed your question, Blue, or your thought. I wonder if the Earth's shadow has ever been cast on Mars before since human observing began. Ooh, yeah, that is good. Yeah, there is that distance at play. Yeah, I wonder if it would be a measurable quantity or measurable quality. I guess quality would really be quality. No, it'd be quantity because you can measure. Yeah, it would have to be quantity because I don't think it would be terribly perceptible at that distance. So you have to measure like almost an infinitesimal decrease in like light intensity. But I mean, I guess when you think about it, you're sort of, whenever a transit occurs, you're sort of in the path of a shadow. It's just, you know, that shadow is spread out over a massive amount of distance. So that's all. I guess that's all you'd have to do is just see a transit of Earth, and then you know a shadow is in the path of the sunlight that's reaching Mars. That's a kind of an interesting thought, because like by that logic, you know, when we're observing exoplanets using the transit method, and they detect them that way, you're sort of in that shadow, right? You're detecting that transit based on the shadow from the planet passing in front of its star. That's fascinating. Really good question. Yeah, I think I'm liking this image data a little better. Not fussing as much with the paddle. It seems to be coming across a little sharper, which makes sense. All right, we'll do one more round, and then we will probably call it a night. So if there's any final questions, put them down in the chat. I could probably, Linda, yeah, I could probably rotate the image through the Streamlabs software like we did before with the moon. I think that would work. Let's see if I can get that to work. Rotate. Yeah, it's not bad. Let's see if I can fill in the space here for you. There you go. That's about where it should be. So yeah, when I do my final final image, I'll make sure to do like a true, like this is how it would be positioned in the as if you were, you know, you're looking at it in with respect to the plane of the solar system. So it would look similar to that. I should have done something like that early on in the stream, but that's okay. Thank you for the suggestion, Linda. I do agree. It looks good. That looks good. I really like the layout of the dark band right now. It looks very nice. Hey, Hazim. Yeah, happy to provide this to you live here at Kopernik Observatory in Vestal, New York. Some decent skies tonight in terms of cloud cover, in that there is none. But not perfect seeing by any means. The seeing could be better. It's improved as the night has gone on, in part because the atmosphere has improved, but also because Mars has gotten higher up in the sky. So we've had some pretty good luck tonight, and tonight was the opposition, or is the opposition, meaning Earth, or the Sun, Earth, and Mars are all in a line in their orbits, and Mars rises just as the Sun sets. So they're on opposite sides of the sky, 180 degrees apart. Oh, there's a coyote or something. Something howled. Not as exposed as when we were doing the meteor shower in August, where I was halfway out the door. The only way something can get in here is through the dome at the moment. Through the dome opening. Which I really shouldn't say that. Yes, I am happy to be inside. I'm not sure if I heard the owl or not. I thought I heard howling, but it could have been an owl too. It was hard to tell. I'm protected in this dome by our own Kopernik owl statue. So hopefully an owl won't try and fly on in here. Alright, I said one more. I kind of want to just wait and see if I can fill up my storage on my computer, because why not? More data the better. Alright, this will be my last go. Yeah, Blue, I'm really hoping. February 18th, we have Perseverance landing on the red planet, landing on Mars. So really eager to see that mission play out, especially with that little helicopter. I'm so curious about that. Hi, Mally. Yeah, exactly. So you looked southeast, straight up in the sky. If you saw that bright reddish object, that was Mars. And that's what we're viewing here through our 6-inch telescope, 6-inch refractor scope behind me here. This is a 6-inch refractor. And we have a camera hooked up to it, designed for astrophotography, and we're seeing some good detail on the surface and even the southern polar ice cap. Or what's left of it. It's really small right now. Yes. Yeah, definitely. I think it's certainly a good time to watch some good Mars movies. Or Total Recall, that's a good one. I think I own The Martian. I think I might watch The Martian sometime this week. I agree. I think it's a good time to celebrate some Mars sci-fi. Yeah, it's a good one. Oh, awesome! Lots of fans of The Martian. It's such a high quality movie. Like the story itself, like the book, the novel is good too. But in terms of like production and uh, uh, the actual design of the props and the amount of detail that went into making a really hyper realistic uh, movie about uh, Mars exploration and actually making it fit within the bounds of science is a it's a feat, and it's incredible. And in part, that's because of the novel itself too, because it was so accurately written. But I love good prop design, and that's uh, evident throughout that movie. Yeah, that windstorm, absolutely. The effects in that movie are incredible. Like watching that movie in 4K, whew, the views of Mars are amazing. Okay, well, as we wrap up my final clip here, I just want to thank you all for joining me tonight. We had some great conversations. I think we might have had even either equivalent or possibly even better attendance to this than the Perseid meteor showers. So really fantastic interaction with you all. Uh, Great questions, and I love that everyone was talking about their Mars observations. It seems like a lot of people had good, clear views of Mars tonight, whether through a telescope or just your eye. So thanks for joining me. If you haven't subscribed to our channel, hit that subscribe button if you want to see more in future observing streams like this one. Mars will be out for a little while. Well, it'll be out for a while yet, for several months. But it will get dimmer as time goes on from this point. And there will be some good opportunities to observe it still over this month and next. So don't miss out. If you have the chance to look through a telescope, go for it. And yeah, if you haven't liked the video, subscribe to the channel, and we'll see you next time. Thank you all.